Guys, is my screen visible? Please ping me. Okay, perfect. So guys, yeah, just give me 1 minute. We are starting. Nishta, am I audible now? Okay, no problem. So guys, the agenda for the day is we will talk about the naive Bayes classifier, the conditional probability, independent dependent events, how the Bayes theorem can be derived. Okay, and then we will implement it, and we talk about 3 different kind of naive Bayes theorems. Then we will talk about one of the document classification problem, which is a natural language processing problem which can be solved using naive Bayes. And then we will talk about the decision tree and the mathematics behind the decision tree, different kinds of decision tree, like there are 5 to 6 different kinds of decision trees. What are the maths behind all of those? So that's what we are going to just talk about today. Before that, let me just start this. Okay. So before we start naive Bayes, हमें कुछ चीजें इम्पोर्टेंट है, जैसे प्रोबेबिलिटी, परम्यूटेशन कॉम्बिनेशन, जो मैंने आप लोगों को पढ़ने को बोला था, तो प्लीज कीप रीडिंग दैट. So I am again telling you, just keep reading about the basic linear algebra, okay, and linear algebra along with the vector algebra. Vector is nothing but a matrix only. मतलब 2 तरह के वेक्टर्स होते हैं. एक होता है आपका रो वेक्टर, जैसे वैल्यूज अगर 1 2 3 4, एक तरह से ये आप इसको लिस्ट कहते हो, राइट, या एरे कह देते हो. ये एक वेक्टर भी है, ये रो वेक्टर है. इसी तरह से अगर इस फॉर्म में है तो ये कॉलम वेक्टर है, 1 2 3. ठीक है, तो ये हो गया हमारा रो वेक्टर और ये वाला हो गया कॉलम वेक्टर. So vector algebra is all around these things. Okay, so read about it. But vector in itself is nothing but a matrix. Like this first one is a spatial matrix whose dimension is 1 into 3. 1 into 3, like 1 row and 3 columns. Similarly, this vector is having 3 rows into 1 column, right? So 3 by 1 का matrix ही कहलाएगा ये. So vector algebra is somewhat related to matrix algebra. So then you will talk about the matrix algebra. Okay, this is one part of the mathematics all together. The another part is about the calculus, where you learn about differentiations and integrations. Okay, that itself is enough. But after the mathematics, the probability comes. Okay, and in probability, like we talked about probability of an event, I gave you certain assignments also, if you guys have done. So probability of an event is nothing but the favorable number of occurrences of that event upon the total possible events that can happen. वो event कितनी बार हो सकता है और total event कितने हैं आपके. So that is favorable upon total, that is your probability. But probability is not that simple. Probability normally comes with multiple events, like probability of two events happening together. For example, probability of A and probability of B. You can say it like this: probability of A and B. So probability of two events has its own mathematics or the formula, but that is आपको देखना पड़ता है कि वो इवेंट्स डिपेंडेंट है या इंडिपेंडेंट है बिफोर यू अप्लाई एनी फॉर्मूला. कि आप दो इवेंट्स के होने की बात तो कर रहे हो साइमल्टेनियसली, बट वेदर दे आर डिपेंडेंट और इंडिपेंडेंट. फॉर एग्जांपल, अगर मान लो मैं कहता हूं कि एक डाइस थ्रो की आपने और आपने एक बैग में से बॉल निकाली, तो डाइस पे 1 आने की प्लस रेड बॉल निकलने की साइमल्टेनियसली क्या प्रोबेबिलिटी है? तो ये दोनों क्या है, एक तरह से इंडिपेंडेंट इवेंट्स हैं, राइट? क्योंकि डाइस को थ्रो करने से बैग में से बॉल निकालने का कोई आपस में कोई कोरिलेशन नहीं है. तो दैट इज इंडिपेंडेंट इवेंट्स, राइट? तो इंडिपेंडेंट इवेंट्स की प्रोबेबिलिटी हम कह सकते हैं प्रोबेबिलिटी ऑफ ए मल्टीप्लाइड बाय प्रोबेबिलिटी ऑफ बी, provided they are independent, right? But if the events are dependent, okay, if the two events are dependent on each other, for example, जो मैंने आपको assignments दिए थे कि एक बैग है जिसमें से आपको बॉल्स निकालनी है और साइमल्टेनियसली दो बॉल्स निकालनी है, तो पहली एंड प्लस आपको विदाउट रिप्लेसमेंट वाला जो केस है फॉर एग्जांपल, तो वहां पहली बॉल निकलने के बाद दूसरी बॉल की जो प्रोबेबिलिटी है निकलने की वो चेंज हो जाती है, बिकॉज टोटल बॉल्स जो आपके बैग में थे वो कम हो जाएंगे, राइट? तो देयर द इवेंट्स आर डिपेंडेंट ऑन ईच अदर. ओके, सो अंडरस्टैंड दैट whenever you are given a probability problem, whether it's asking you to solve a dependent or a independent event, and accordingly the formulae and the approaches they changes. Probability के साथ में आपको definitely permutation और combinations बहुत जगह काम आती है, so that is another thing. Okay, so this is about maths and probability. And then the third thing that comes is statistics. Okay, the statistics, where we talk about mean, median, mode, we talk about the data distributions, right? So what happens is we talks about the different data distributions, we talk about the skewness, we talk about the kurtosis. Okay, there are a lot of different things. We talk about PDF, like PDF की full form कोई बताएगा? Statistics में what is PDF? Statistics में? Yes or no? We can. Very good, Pragisha. Good. So probability distribution function or probability density function. So there are different kind of PDF formulas that are available. So why I am talking about this is important, because ये तीन चीज करने के बाद machine learning start होती है. Once you do maths, probability and stats, then comes your modeling or the machine learning. Okay, but yeah, when we talk about probability distribution functions, guys, what are different probability distribution functions you are aware about in the field of statistics? Different PDF functions. Anyone? One is the normal distribution function. Okay, this one, the one on my screen. Yes, this is the normal distribution function. But normal distribution function is further of another type known as standard normal distribution. Standard normal distribution में क्या होता है? अभी ये कर्व यहाँ पर है. Standard normal distribution curve will be like this. Will be like this. Okay, फर्क क्या हुआ दोनों में? ये जो है ये आपका या वर्षा, ये आपका क्या है? ये आपका नॉर्मल डिस्ट्रीब्यूशन है, ये आपका स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन है. दोनों में फर्क क्या होता है? कि ये जो पीडीएफ फंक्शन है इसका मीन जो है वो 0 है, ओके, और इसका स्टैंडर्ड डिविएशन जो है वो आपका 1 का रहेगा. Standard deviation of say this is 1, and normally we talk about all the data to lie within 2 standard deviation. Normally chi-square distribution is different, yeah, right? So guys, remember about statistics. Statistics is very important, where we talk about probability distribution functions. What is normal distribution, what is difference between the normal and standard normal distribution. बट ये जो डिस्ट्रीब्यूशन फंक्शंस की मैं बात कर रहा हूं यहाँ, ये किसकी है? ये कॉन्टिन्यूअस डेटा की है. नंबर्स मतलब कॉन्टिन्यूअस न्यूमेरिक वैल्यूज, राइट? कॉन्टिन्यूअस नंबर्स. बट देन यू हैव डिस्क्रीट नंबर्स आल्सो, राइट? लाइक 1 2 3. तो इन दैट केस आल्सो वी हैव डिफरेंट प्रोबेबिलिटी फंक्शन, पीडीएफ फंक्शंस. ओके, तो कैन एनीवन टेल मी फ्यू नेम्स? डिस्क्रीट न्यूमेरिकल डेटा जब होता है तो हमारे पास कौन कौन से पीडीएफ अवेलेबल हैं, या कौन से डिस्ट्रीब्यूशन फंक्शंस या डेंसिटी फंक्शंस अवेलेबल हैं? एनी वन गाइस? बर्नौली आपने सुना हो, बाइनोमियल या बर्नौली? यस प्रगिशा, करेक्ट. सो बाइनोमियल डिस्ट्रीब्यूशन और द बर्नौली डिस्ट्रीब्यूशन, राइट? आप लोगों ने कहीं ना कहीं पढ़े होंगे ये चीजें. बट रिमेंबर, when you have continuous data, you have to talk about the probability distribution functions like these. There are more, okay? Normal distribution, standard normal distribution. इसके अलावा there is exponential distribution, और भी बहुत सारे distributions होते हैं. Similarly, discrete data के लिए हमारे पास probability density function होते हैं, जैसे कि बर्नौली या बाइनोमियल. उसमें भी पॉजिटिव बर्नौली, नेगेटिव बर्नौली. देयर आर different functions. There is Poisson distribution. There is Poisson distribution also. Okay, guys, read about these things like Poisson distribution. These are important. And then definitely the things which we will talk about, some statistical tests like t-test, z-test, chi-square test, ANOVA test. These are our statistical tests, parametric, non-parametric tests, which we will talk about. But इतना आपको अगर आपको आता है, it is more than enough. Okay, the first one is in statistics is definitely the mean, median, mode, and the outlier detection. There are formulas for that. Okay, like there is something known as Chebyshev's theorem. Remember this. There is Chebyshev's theorem. So just remember, this is something important. Chebyshev's theorem. What is Chebyshev's theorem? जिसको आप 96% of your data, or 99% of data lies within three standard distribution, right? So वो Chebyshev's theorem ही कहलाती है. Empirical formula भी कहते हैं कुछ लोग उसको. Okay. And after that, this probability distribution functions, which you should read, and yeah, then we will talk about this. Okay. Next, you have some question. Okay. So we are moving ahead now. So as you have been asked last time, right, to read about few things. One second. Okay, and one more thing, like जैसे कि आपके guys parametric, non-parametric statistical test होते हैं, वैसे ही parametric और non-parametric models भी होते हैं. Okay, so the machine learning models. So Nishtha, these tests are not to test the accuracy of any models, the t-test, z-test as such. They are just to compare the data distributions. The t-test, z-test, they, अगर मान लो मैंने आपको अमेरिका की पॉपुलेशन दे दी और आपको जर्मनी की पॉपुलेशन दे दी, और आप उन दो पॉपुलेशंस को आपस में कंपेयर करना चाहते हो, तो आपके पास एक कॉमन स्केल या स्टैंडर्ड होना चाहिए उनको कंपेयर करने का। ठीक है, कि अमेरिका की यंग पॉपुलेशन है या इंडिया की यंग पॉपुलेशन है, या फिर जैसे होता क्या है नॉर्मली, जैसे साइंटिस्ट कैसे काम करते हैं, मान लो आपके पास दो फार्म्स हैं, राइट, फ्रूट फार्म्स, एक फार्म की प्रोडक्शन अच्छी हो रही है, दूसरे की बुरी हो रही है, राइट, ईयर ऑन ईयर एक की तो बढ़ रही है लेकिन दूसरे की घट रही है। तो व्हाट यू नीड टू डू, यू नीड टू capture some data for farm A and then some data for farm B to compare कि भाई आखिर इनका जब मैं डिस्ट्रीब्यूशन ग्राफ्स बनाऊंगा तो हाउ कैन आई कंपेयर दीज, कि हो सकता है एक कह रहा है कि मेरी डिस्ट्रीब्यूशन कम है, बट ग्राफिकली हाउ कैन आई कंपेयर दीज टू डेटा। इसीलिए टी टेस्ट को जैसे टी डिस्ट्रीब्यूशन टेस्ट भी कहते हैं या स्टूडेंट्स टेस्ट भी कहते हैं। तो we will talk about it, but it's like कि आपके पास दो स्कूलों के बच्चे हैं, आपको उनको कंपेयर करना है, तो आइडली तो यू कैन नॉट कंपेयर, राइट, बिकॉज एक स्कूल की एजुकेशन अलग तरीके की है, दूसरे की अलग तरीके की है, बट you need some common comparison statistics, so that's where we use it, okay, whether it's students from different schools, whether it's your farm produces from different farms, or whether it's population of different countries. So or when you have different samples, for example you want to compare two samples to each other, क्योंकि हो सकता है कई बार मान लो आपने एक डेटा लिया जिसपे मशीन लर्निंग इंप्लीमेंट करनी है, और उसमें आपने एक सैंपल लिया, डेटा सैंपल, रैंडमली पॉपुलेशन में से एक सैंपल निकाल लिया, ठीक है, ये मेरी पॉपुलेशन थी, आपने इसमें से एक सैंपल निकाल लिया और मशीन लर्निंग मॉडल इंप्लीमेंट कर दिया, मैंने भी दूसरा सैंपल निकाला, मैंने भी इंप्लीमेंट कर दिया, लेकिन मेरा मॉडल ज्यादा एक्यूरेट आ रहा है, आपका एक्यूरेट नहीं आ रहा। इसके पीछे क्या गलती है कि भाई आपने जब ये डेटा लिया तो आपने क्या ये चेक किया कि आपके जो कॉलम्स जो हैं, मान लो एज कॉलम, वो एज कॉलम नॉर्मली डिस्ट्रीब्यूटेड था, हो सकता है जब आपने यहाँ से सैंपल लिया तो उसमें जो लोग आए वो ऑलमोस्ट सेम ही एज कैटेगरी के आ गए, राइट, तो आप जो मॉडल भी इंप्लीमेंट करोगे इट वॉन्ट बी गुड। तो यू नीड टू फर्स्ट सी कि भाई मैं जो डेटा पॉपुलेशन में से इवन अगर मल्टीपल सैंपल्स भी बना रही हूँ तो क्या इन सब सैंपल्स के अक्रॉस मेरी डेटा डिस्ट्रीब्यूशंस किसी एक पर्टिकुलर डिस्ट्रीब्यूशन फंक्शन को फॉलो कर रही हैं, उसके बाद ही मैं मॉडल लगाऊं, राइट। अदरवाइज मेरा मॉडल जो होगा वो ओवरफिट हो सकता है, अंडरफिट हो सकता है, देयर आर लॉट ऑफ सच थिंग्स रिलेटेड टू this which distributions helps you, okay, yeah, so you can even compare two samples which are coming from the same population also using the distribution functions. That's about the distribution functions, the statistical tests and distribution functions, okay. So similarly our machine learning models are also of two types, parametric and non-parametric, where parametric models are the one where we normally talk about certain limited parameters, like अगर आप एक लीनियर रिग्रेशन विद टू वेरिएबल्स इंप्लीमेंट कर रहे हो तो गाइस कितने पैरामीटर्स होंगे इस मॉडल के जिनको उसे लर्न करना है। एक लीनियर रिग्रेशन मॉडल with two features will have how many parameters, guys, that it needs to learn? I'm not talking about the hyperparameters, I'm talking about the parameters that it needs to learn. Guys, a linear regression model with two features needs to learn how many thetas? How many thetas? No one is correct till now. 0, 1 and 2, Karandeep. Yeah, Karandeep, okay, 0, 1 and 2. So I'll take it as right. It's three parameters. Okay, not 0, 1 or 2 as such, but yeah, it's theta naught, theta 1 and theta 2, or beta naught, beta 1 and beta 2, guys. This is the slope for first, slope for second feature, and this is the intercept, right? Whenever you learn a linear regression, समझ गए ना? जब भी आप लीनियर रिग्रेशन मॉडल रन करते हो तो लीनियर रिग्रेशन मॉडल में फाइनली जो आउटपुट निकलता है वो जिन चीजों को लर्न करता है वो तो पैरामीटर्स है ना. ग्रेडियंट डिसेंट प्रोसेस आखिर हो क्यों रही है? टू गेट यू द बेस्ट वैल्यू ऑफ दीज थ्री थिंग्स, राइट? Once you get the best value of these three things, you can throw away your training data. You don't need your training data anymore. Okay, so that's what your parametric models are, where you learn certain parameters, but once these parameters are known to you or they are learned, you can throw away the training data. You no longer need it, because the future data that is there does not need it, right? That does not need the training data. It just needs the parameters. This is one of the very basic way of explaining you, but ultimately whether you throw this training data or not, the point is आपकी इक्वेशन तो सिर्फ स्लोप से बन जाती है, right? So that's the parametric models, whether it's linear regression, whether it is logistic regression, whether it is support vector machine. हर एक में हमने जब बात की थी, we were just focus on these. So जब हमने logistic regression की भी बात की थी तो we talked कि आपका logit function लगता है और logit function finally आपका एक straight line को डिसीजन बाउंड्री को प्रेडिक्ट करने की कोशिश करता है, तो उसके ही स्लोप्स वगैरह आइडेंटिफाई किए जाते हैं. तो लॉजिस्टिक रिग्रेशन, सपोर्ट वेक्टर मशीन, ये सब मॉडल्स भी इसी पैरामीट्रिक कैटेगरी में फॉल करते हैं. दैट यू नीड टू आइडेंटिफाई द पैरामीटर्स. ओके, आई एम नॉट टॉकिंग अबाउट हाइपर पैरामीटर्स. ओके, हाइपर पैरामीटर्स आर यूज्ड टू गिव यू द बेस्ट वैल्यू ऑफ दीज पैरामीटर्स. Okay, hyperparameters like learning rate and all are used to give you the best value of the parameters. So the first point in the parametric models is that they give you parameters, but the point is they give you finite number of parameters, guys. Means whenever you are implementing a parametric model, you know how many parameters are going to generate. That's what the parametric models are. But the non-parametric model, they can be further of two types. The ones where you don't have any parameters, or second where you have the parameters but it's not defined. Means it can keep increasing. The more the data you pass, the more the parameters. Okay, so what happens is in the non-parametric, it's you don't have finite parameters. Your parameters depends on your data. For example, अगर मैं पैरामीट्रिक मॉडल की बात करूं तो चाहे मैं 1000 रिकॉर्ड पास करूं या 1 लाख रिकॉर्ड पास करूं, मेरे हमेशा ये तीन ही पैरामीटर होंगे, उससे ज्यादा नहीं हो सकते, राइट? कम भी नहीं हो सकते. ठीक है, कम आप इस तरह से कह सकते हो कि इस θ1 की वैल्यू 0 है, बट वो उसकी वैल्यू 0 है. आपके पैरामीटर्स अभी भी 3 है, इसकी वैल्यू 0 निकली है. Okay, but still you have 3 parameters, but in non-parametric it can be more. So the point here is then which are these parameters, non-parametric models. So here you talk about the KNN. KNN does not give you any parameters. Okay, it simply is a memory based model कि वो अपना मेमोरी में ही सब कुछ रखता है और जब भी आप कुछ प्रेडिक्ट करते हो वो उसी डेटा पे चलता है. नाइव बायस, राइट? नाइव बायस एक्चुअली falls under both the categories of non-parametric, parametric, but abhi ke liye let's keep it here. You read more about it, we'll talk. So naive bias, decision tree. Okay, decision tree. So all these are non-parametric models, the ones that we are going to talk. KNN, naive bias. Naive bias has both the implementations, I'll tell you. And then decision tree. For example, decision tree की बात करते हैं. डिसीजन ट्री में जितना ज्यादा डेटा पास करते चले जाओगे आपका ट्री उतना बड़ा बनता चला जाता है. ये अलग बात है कि आप उसको प्रून कर सकते हो, वो अलग बात है, बट मोर द ट्रेनिंग डेटा यू पास द बिगर द ट्री कीप्स ऑन बिल्डिंग, राइट? सो उसकी डेप्थ उतनी बढ़ती चली जाती है. and consider the depth as its parameters, for example, right? Height as a parameter, for example. So it keeps increasing, right? Or the number of nodes, they keeps increasing. Okay, height, depth, width, whatever you want to say. So KNN, naive Bayes, decision trees, these are all non-parametric models. So understand these things, read more about it. What are parametric models? What are non-parametric model? Parametric have finite number of parameters. Non-parametric either may not have any parameter, or if they have, it changes with the change in the data. If you increase the data, it increases. If you decrease, it decreases. For example, अगर मैं बात करूं कि नॉन पैरामेट्रिक मॉडल है जो कि थीटा लर्न करता है, तो कम डेटा पे वो थीटा नॉट, थीटा वन, थीटा टू दे रहा है, ज्यादा डेटा पे वो थीटा थ्री, थीटा फोर, थीटा फाइव दे रहा है. तो दे आर द डिफरेंट मॉडल्स. लाइक we have certain advanced models, not basic models, but HMM. These are your Gaussian models, HMM models. HMM models are some Markov models. Markov models भी मतलब यहाँ पर भी आप देख रहे हो, but यहाँ पर है infinite HMMs and these are HMMs. These are interesting things to study if you are you want to. Hidden Markov models and infinite hidden Markov model, but ये आपको already पता होगा. K means, right? Mixture models, like mixture models. Mixture models are nothing but clustering models. Okay, yeah, understood. So mixture models have their, mixture models are exactly not unsupervised models, but mixture model is one of the advanced clustering model. Okay, mixture model. This is there is MM models and I think Gaussian MM models. So these are your mixture models, which like K means clustering is one kind of clustering. Mixture models is another kind of clustering. It's a clustering algorithm. Okay, PCA, leave about this. Factor analysis. Factor analysis is nothing but it's another unsupervised learning thing, which we normally talk about with PCA. You try to analyze the factors, factors as in your main primary features. So we do the factor analysis. Okay, so guys, I'm just pinging you this link. You can read this link. There are much better links also, but yeah, just read about parametric, non-parametric models. Like there are parametric, non-parametric statistical tests. But we can decrease the theta. Karandeep, what do you mean by decreasing the theta there in PCA?
अरे फीचर्स कम कर लेते हैं ना.
No, so we are not talking about features here, na. We are talking about
सर ऑडिबल नहीं है, क्या बोल रहे हो?
Guys, am I audible? I think there was a network disconnect. Yeah, I know. I connected to a different network. Perfect. Yeah, so there was some disconnect. So what we were talking about is, yeah, so Randeep, the question is, which parameters you are talking about? Like n plus 1, when you talk about which parameters, because there are a lot of different parameters in PCA. If you talk about the exact formula, which parameter you're talking about? Like when you say n plus 1.
सर सपोज लीनियर में होता है तो जितने वेरिएबल्स हैं उसके लाइक थीटा नॉट हो जाएगा थीटा 1 एंड थीटा 2, राइट?
In
बट
PCA you are
पीसीए
saying?
नहीं
हाँ,
नहीं, इन लीनियर रिग्रेशन आई एम सेइंग, बट इन
हाँ,
PCA we are decreasing those, no, कि अगर suppose there are 100 variables तो we decrease them to 2 3 or whatever number.
yes, correct.
So how does that fall into parametric? Like we can increase decrease our like the thetas whatever.
Okay, got it. Okay. So see. So when I am talking about the parameters, okay, I thought this. So when we talk about parameters, ऐसा नहीं है कि ये I gave you the example of linear regression where you normally understand theta naught, theta 1, theta 2, और ये आपको पता है कि they are directly correlated to your features. अगर आपके पास मान लो ये तो कोई फीचर ही नहीं है, ये आपके पास x1 है और ये आपके पास x2 है, राइट? तो लीनियर रिग्रेशन में इट इज फाइन दैट थीटा नॉट, थीटा 1, थीटा 2 का क्या मतलब है? वहां थीटा 1 का मतलब है कि वो इसका स्लोप है, राइट? थीटा 2 का मतलब है वो इसका स्लोप है, राइट? बट मैं ये कह रहा हूं कि फॉरगेट अबाउट दिस थिंग, just consider these thetas as something which your model is learning. Okay, don't say that they are correlated to the features. वो तो लीनियर रिग्रेशन, लॉजिस्टिक रिग्रेशन में होता है, but I am saying that your model is learning some parameters to solve a particular problem. So those parameters, if you increase the volume of the data, not the features, because अगर आप लॉजिस्टिक रिग्रेशन की भी बात करोगे, अगर आप अपने फीचर्स बढ़ा दोगे तो उसमें भी आपके थीटा 3, थीटा 4, थीटा 5 ऐसे होने शुरू हो जाएंगे, राइट? I am talking about the data volume, not the features. If you increase decrease features, तब तो आपका लॉजिस्टिक रिग्रेशन है, पॉलिनोमियल रिग्रेशन में भी वही है. So the point here is when you increase or decrease the data volume, as in the number of records, not the features. Okay, because if you change the features, this will change. Okay, so that is one thing. And PCA में जो आउटपुट निकलता है वो, अब अगेन द पॉइंट हियर इज, आप आउटपुट क्या निकालना चाह रहे हो? पीसीए में भी आप आउटपुट क्या निकालना चाह रहे हो? फॉर एग्जाम्पल पीसीए में आप काम कैसे करते हो? आप कहते हो कि मुझे 2 पैरामीटर्स चाहिए, बट उसके पीछे जो कैलकुलेशन होती है आइगन वैल्यू आइगन वेक्टर, if someone remembers the eigen value eigen vector, so that formulae, the way it creates the covariance matrix, so there is this covariance matrix that gets created, and the calculation that happens is actually happens in a parametric way. I need to tell you the formula. For that we need to talk about the eigen value eigen vector and this thing, the SVD, singular value decomposition, to understand it. But one thing that you should remember is, when I am talking about parameters, and these parameters don't directly bind it to your features, कि हमेशा जितने फीचर्स होंगे n+1 ही मेरे पैरामीटर्स होंगे. इट इज फॉर द रिग्रेशन मॉडल्स आई एम टॉकिंग अबाउट. फॉर एग्जाम्पल व्हेन यू टॉक अबाउट लाइक के मीन्स, तो के मीन्स का काम करने का तरीका अलग है. So k-means does not learn for a parameter like theta naught, theta 1, theta 2. it has its own defined set of parameters. Can anyone tell me what a K-means clustering model try to learn? Which parameter it try to learn? So even in K-means, guys, if you pass say 100 features, ऐसा नहीं है कि वो 101 parameters बनाता है पीछे. There is some specific parameters it looks at. Can anyone tell me which parameter K-means actually works on? Similarity in data points, but which parameter it actually try to learn, so that you don't need the training data in future. See, consider it like you are learning something so that you don't need training data in future. So what parameter you need in K-means as output? आप K-means को train क्यों करते हो? What is the purpose of passing the training data to K-means? Which parameter it learns? Okay. Number of clusters, Pragesha, is a hyperparameter. What the model learns, Rahul, you are correct. So what happens is, guys, centroid, right? It's learning the parameter which is the centroid. Okay, so now the point is, if you learn a K-means algorithm and you say, I need say 4 clusters, you say a hyperparameter is 4, then you run this model today, you run it after 10 years, it will learn 4 parameters which are 4 centroids. Okay, it will learn always 4 centroids. आप आज K-means रन कर रहे हो 100 फीचर्स पे, ठीक है, आप 100 फीचर के बेसिस पे लोगों को 4 क्लस्टर में डिवाइड करना चाहते हो, ठीक है. क्वेश्चन बिल्कुल वैलिड है आपका. लेट मी ट्राई टू एक्सप्लेन यू. मैं कह रहा हूं कि आप K-means क्लस्टरिंग 100 फीचर्स पे चलाते हो, लेकिन आप कहते हो कि आपको 4 क्लस्टर्स ही चाहिए. You are running K-means on 100 features, but your K is 4. You are, guys, I think someone needs to mute. Okay, so it will always learn 4 parameters. Okay. Now tomorrow I increases उसी मॉडल में मैंने 1000 फीचर कर दिए, लेकिन still the parameters, मतलब मुझे क्लस्टर 4 चाहिए थे तो 4 ही सेंट्रोइड वो लर्न करेगा, right? Even if I increase the data or decrease the data, it will still learn the same 4 centroids, so that if tomorrow a new record comes, it will calculate this Euclidean distance from each of these 4 and tell कि इन 4 में से मैं किसके नियर हूं. तो K-means क्लस्टरिंग में आपको सिर्फ सेंट्रोइड वैल्यूज अगर पता है, लाइक x1 x2 पहले सेंट्रोइड की वैल्यू हो गई, फिर x2 मतलब सॉरी x1 y1 x2 y2 x3 y3 x4 y4, तो आपका कोई नया डेटा पॉइंट जो होगा वो सीधा सीधा अपना यूक्लिडियन डिस्टेंस कल को कैलकुलेट करेगा और बताएगा कि मैं किस क्लस्टर में बिलोंग करता हूं, राइट? तो I understand the questions are absolutely valid. Read more about it. ये चीजें थोड़ी मतलब होता है डाउट, कंफ्यूजन होता है. Read about it more. But I hope you got it. Like अगर मैं K-means का एग्जांपल आपको दूं, तो similarly you need to first know कि आपका मॉडल लर्न क्या कर रहा है, वो उसके पीछे मैथ्स क्या है और उसका आउटपुट क्या है. If you know that, you can easily fit in any of these. जैसे मैं कह रहा हूँ नाइव बायस दोनों में फॉल करता है, मतलब उसके दोनों वर्जन्स हैं, तो वहां पे हमें फिर और डिटेल में समझना पड़ता है. बट जस्ट ट्राई टू रीड मोर अबाउट इट. This is what I want to tell you, the intuition behind parametric models and the non-parametric models. Okay, so let's go to this thing. Okay, so we were talking about some statistical distribution functions, and then this thing, the parametric non-parametric models. But now the important thing, which is the naive Bayes model, which we were talking in the last class, is given the training data, you want to learn some parameters. Here also you want to learn certain parameters so that you can do the future predictions, right? So as to learn the future predictions, the parameters that it learns actually are nothing but the probabilities. So the naive Bayes model, on your training data, it learns nothing but probabilities, so that the same probability values can be used in future. For example, if you pass on the data, like what example I'll give you, if this is this, okay. So say you have gender, you have genders as like male, then female. Let's consider 3 records, and whether to give a loan or not. So say it was yes, it was no, and say it was yes. So let's keep it simple. How naive Bayes will work. So this is your feature, this is the feature, and this is the target. Okay. So based on this input data, where you have certain features and then the target, how the model will learn these things is, first of all, model will try to learn the probability of the classes. So say my positive class is y and negative class is like n, whether to give loan or not. So positive class is say denoted by 1 and negative is by 0. Okay. So positive class by 1, negative by 0. So here, first of all, I need to calculate the probability of the class, as in nothing else exists. So just looking at this column, the probability of this being yes is how much? 2/3, right? कि in general, अगर मैं gender को भूल जाऊं, yeah, Nishta, this is Bayesian equation only, yeah. तो अगर मैं जेंडर की बात ही ना करूं, मतलब इररिस्पेक्टिव ऑफ द फीचर, मैं कहता हूं जो भी मेरे पास आता है, अगर मेरे पास 1000 एप्लीकेशंस आती हैं, उनमें से मैं कितने लोगों को यस बोलता हूं, कितनों को नो बोलता हूं, in general, without talking about any feature, forget about the feature. So 2/3 and 1/3. So this is your class probabilities. Okay, the class probability that comes from your training data. Okay, so it's 2/3 and 1/3. Then the predictor prior probability, as in the column that you have, right? So that column, whichever column you have, here we have this feature, right? So here, what is the probabilities, as in how many males are there and how many females are there? Like probability of a male and probability of a female, irrespective of this column, just forget it. So probability of male and say probability of female. So probability of male will be how much here? Again, it's 2/3 and female is 1/3. So you know the predictor probability, you know the class probability, but now your model also needs to calculate the likelihood. Now what is likelihood? So likelihood से पहले हम ये समझते हैं कि भाई हमें निकालना क्या है, हमें प्रिडिक्ट करना है कि probability of a particular class given a particular feature. Means say probability, it can be like probability of giving a loan, okay, giving a loan provided that person is a male, is one of the posterior probability. Similarly, the probability of not giving a loan given that person is a male, that is another posterior probability. So how to calculate that? So we are just talking about the first one, probability of y given m. So what it should be? So that will be the probability of m given y. ओके मतलब इसका मतलब क्या है कि जितने भी लोगों को लोन दिया गया उसमें से मेल्स कितने थे, जितने लोगों को लोन दिया गया उसमें मेल कितने थे, जबकि ये यहां पर जो है वो क्या है, वो है प्रोबेबिलिटी ऑफ y और ये क्या है नीचे प्रोबेबिलिटी ऑफ मेल। मतलब ये जो है ये है कि टोटल जितनी एप्लीकेशन आई लोन में उसमें मेल कितने थे, लेकिन ये क्या है जितनों को लोन दिया गया है उसमें मेल कितने हैं, देयर इज अ डिफरेंस राइट। सो प्रोबेबिलिटी ऑफ मेल गिवन y, तो y कितने हैं 1 एंड 2 राइट। तो टोटल आपके आउटकम्स हैं 2, लेकिन फेवरेबल कितने हैं आपके 1, तो इट्स 1/2 मतलब 50%। तो जितने भी लोन दिए गए हैं उसमें 50% मेल्स को और 50% फीमेल्स को दिए गए हैं। सो प्रोबेबिलिटी ऑफ प्रिडिक्टिंग y given m is probability of my, probability of y divided by probability of m. Okay, so now if you put all the values in this formula, we have 1/2 multiplied by probability of y, which is मतलब लोन देने की कितनी probability है, which is 2/3, and total क्या है probability of being a male, that's again 2/3. So if I solve this, ऐसा तो ये कट ही कर देगा, तो यहाँ पर तो ये एक 50% प्रोबेबल मॉडल निकल के आ रहा है मेरे पास, जहां पर अगर कल को मैं कहता हूं कि मेरे पास एक एप्लीकेशन आई, नई एप्लीकेशन टेस्ट डेटा में, और वो पर्सन जो है वो मेल है, तो क्या हम उसे लोन दें या ना दें। तो लुकिंग एट व्हाट मॉडल हैज लर्न, मॉडल रियली डिडंट लर्न एनीथिंग कंक्लूसिव ऑन द डेटा दैट आई हैव, it's just a 50-50% chance that what my model has actually learned here. So guys, this is how the naive Bayes model works. Probability of positive class given a particular feature is probability of feature existing in all the positive classes, लाइक कितनी पॉजिटिव क्लासेस की एंट्री थी ट्रेनिंग डेटा में जिसमें वो वैल्यू एग्जिस्ट कर रही थी, प्रोबेबिलिटी ऑफ द क्लास एंड प्रोबेबिलिटी ऑफ दैट फीचर, लाइक से इट्स जेंडर, इट कुड हैव बीन एनीथिंग। तो ये आपका एक फॉर्मूला है, ये अभी हम इंप्लीमेंट करेंगे, 1 सेकेंड। बट बिफोर दैट वी विल टॉक अबाउट द डेरिवेशन। समटाइम्स इन इंटरव्यू they ask you the derivation of this formula. Formula is very simple, but how it is derived. So if you look at it, the intuition behind the derivation of this formula is coexistence of two things, C and X. Means what is the probability that both of these occurs together? So somehow this is what it is telling you. Not exactly, it's a conditional probability, but if you start your initial starting point, so it's something like I am talking about probability of two things, C and X, existing together. That's what conditional probability is, right? Probability of this given this, मतलब क्या probability है कि मैं बाहर खेलने जाऊं given there is sun outside, so means both things are existing together. Yeah, so to start the intuition we can talk about this formula. So we can start our derivation from this formula and then we can reach to this conclusion. So let's see that. So this is what I want to show you. This is what the Bayes theorem is. The Bayes theorem in general talks about probability of two events happening together, probability of A and B. By logic or by common sense, it's known that probability of A and B is equal to probability of B and A, as in कि यहाँ पर वो परम्यूटेशन कॉम्बिनेशन वाला चक्कर नहीं है कि पहले बाद में, दो चीजों के साथ में होने की क्या प्रोबेबिलिटी है. तो फॉर एग्जांपल कि अगर मैं कहता हूं कि आप दो डाइस को थ्रो कर रहे हो, तो दो डाइस को थ्रो करना अपने आप में इंडिपेंडेंट इवेंट है, राइट? या प्रगेश करेक्ट. सो दो डाइस को थ्रो करना अपने आप में इंडिपेंडेंट इवेंट्स हैं. टू डाइस आर नॉट डिपेंडेंट ऑन ईच अदर, राइट? तो whether I get 1 on the first and 2 on the second, so I say what is the probability of getting say even number on the first and the odd on the second. So these are independent to each other as such. So the point is probability of two things happening simultaneously, probability of A and B or probability of B and A is same. So now the formula for probability of A and B, is probability of A multiplied by probability of B given A. Okay, so this is actual formula that we talk about. Probability, sometimes people say that probability of A and B is probability of A multiplied by probability of B, but वो इसी फॉर्मूले में से निकला है. प्रोबेबिलिटी ऑफ ए एंड बी इज, ये एक्चुअल फॉर्मूला है और इसी फॉर्मूले से ये फॉर्मूला निकला है कि प्रोबेबिलिटी ऑफ ए मल्टीप्लाइड बाय प्रोबेबिलिटी ऑफ बी प्रोवाइडेड टू इवेंट्स आर इंडिपेंडेंट. ओके, बट in general if you talk about dependent, independent, this is the formula, or you can say this formula is for dependent events because probability of B changes once A has happened. Okay, but I'm not going into the probability theory here. So I'm saying probability of A intersection B is having this actual formula, but this formula can also be converted into this if events are independent of each other. Okay, but leave it. So this is the main formula, which is probability of A, and क्योंकि A already हो चुका है, then probability of B given A has already happened. Okay, and if these are dependent events, it will change. Similarly, probability of B and A is probability of B dot probability of A given B has already happened. Okay, so ये हमारे पास यहाँ पर दोनों के फॉर्मूले निकले. ये हमें बाय इंट्यूशन पता है जॉइंट प्रोबेबिलिटी इज कम्यूटेटिव इन नेचर. ओके, जॉइंट प्रोबेबिलिटी इज कम्यूटेटिव इन नेचर. you have in maths there is associative and commutative, and then there is one more, transitive or translative. I think there are three main properties in maths, and this field of maths is known as discrete mathematics. There is another field of maths which is discrete mathematics where we talk about set theory. Like this is one Venn diagram, this is another Venn diagram. Guys, probability कहाँ से निकली है actually? So if this is like one set, this is another set, this is the overlapping set, right? मतलब ये वो स्टूडेंट्स हैं जो स्पोर्ट्स में अच्छे हैं, ये वो हैं जो स्टडीज में अच्छे हैं, ये ओवरलैप वो हैं जो स्पोर्ट्स और स्टडीज दोनों में अच्छे हैं. तो वेन डायग्राम से भी मैं प्रोबेबिलिटी निकाल सकता हूँ कि भाई प्रोबेबिलिटी या और भी बहुत सारी चीजें. तो ये डिस्क्रीट मैथमेटिक्स से निकला जहां हम कम्यूटेटिव एसोसिएटिव प्रॉपर्टीज की बात करते हैं. बट for data science, maths is one important things. Okay, you cannot skip it. Okay, so probability of A and B is equal to probability of B and A, and these are the formulae. When we equate or substitute those two values in the equation 3, you will get this, and now you have to just move this value in the denominator here, probability of B here. It will give you probability of A given B. So this is how you have to do the derivation. If in interview someone asks you, can you derive the Bayes theorem? You should. Okay, and it's very simple. If you know probability of A and B is probability of B and A, the formula, don't use this formula because this is for independent events. So we are talking about this thing, and this is where we finally conclude it. Okay, how the naive classifier works. So guys, naive Bayes is just a special form of Bayes theorem. So Bayes theorem का special form है naive Bayes. So if you just look at the above thing, so this is Bayes theorem, which gives you the equation for conditional probability. Okay, how it changes for naive Bayes is very simple. It says probability of target given feature 1, feature 2, feature 3, feature 4, feature 5, like that. So you want to calculate the probability of a target given certain features. In the above equation, we were only talking about one feature. For example, probability of A given only one feature, but naive Bayes is probability of target given multiple features. So the equation will be simple, जैसा ऊपर है. So you have to get this likelihood, which is the probability of all of these in when your target was having y or n. What is the probability of y and what is the probability of x1, x2, x3, x3, and like this. Okay, now we can calculate this probability easily, we can calculate this easily, but we cannot calculate this easily. Means it's overhead. So here what they did, like the naive Bayes thing they did is, it says that I have to calculate probability of x1 and x2 and x3 and x4 and xn. So consider that all of these features are independent features. This will become probability of x1 multiplied by probability of x2 multiplied by x3 multiplied by x1. So to help solving you this denominator, the concept of independence of the event helps you. Otherwise, solving this could have been a problem. So this denominator is probability of x1 multiplied by x2 multiplied by x3 and so on, and then you can multiply all those probabilities like we talked in the dummy example that I showed. However, in naive classifier, what they say is that you can also remove it, means it does not have much impact on the actual prediction. However, I don't want to tell you that thing. We want to keep it probability of x1, x2, x3, x4 because naive Bayes को naive ही क्यों कहते हैं? Because it underlying assumption is all the features are independent of each other, which is not true in the real world. Okay, so remember that's what the naive Bayes is. That's no collinearity, Anishta. So ultimately, guys, you need to remember probability of dependent events and independent events, the derivation, and how this gets converted into the naive Bayes, which is this thing. And the below formula will become the multiplication of individual probabilities, probability of x1, probability of x2, x3 because of independent features, and that's what the model do. Now, the naive Bayes model is of three types. Okay, naive Bayes model is of three types. Okay, one second. So naive Bayes model, when we implement, we have three hyperparameters which tells कि naive Bayes model किस type का है. Gaussian, multinomial, and Bernoulli. So guys, there are three kinds of naive Bayes model. So जब भी आपको डेटा दिया गया है, आपको naive Bayes मॉडल लगाना है, तो आपको ब्लाइंडली नहीं लगाना है. आपको डिसाइड करना है कि इन तीनों में से कोई एक ही मॉडल मेरे डेटा पे सही काम करेगा. मतलब दूसरे भी काम कर जाएंगे, वो ऐसा फेल नहीं होंगे, बट आपकी एक्यूरेसी उतनी अच्छी नहीं होगी. सो what's the difference between three naive Bayes models? It's asked in the interviews. Okay, so Gaussian naive Bayes, again it depends on your features, guys. Say you have a feature age. If you have only feature age and you want to predict something, we know that age is a numerical value, right? And this numerical value will have a normal distribution curve like this. It's a continuous numerical value. So if all my features are of the type continuous numerical values, I should use Gaussian, because this is nothing but Gaussian distribution. हम normal distribution को Gaussian distribution भी कहते हैं, इसलिए इसका नाम है Gaussian naive Bayes. So there is a model known as Gaussian NB, which we will implement. Then there is this one, which is very, very important, which is multinomial NB. So multinomial NB is when you have a feature which takes discrete values, as in 1, 300, any such values. For example, the number of mobiles I own. Okay, so number of mobiles someone owns. Someone may have 1, 3, 10. 100 is a very exaggerated term, but it's fine. Or if someone is having how many bank accounts he has, you want to see whether a person is defaulter or not by looking at how many bank accounts he has. So too many bank accounts is also not good. Okay, so someone is having, say, 20 bank accounts, someone is having 1, someone is having 3. So that's also is a very important indicator. Okay, whether a person is having too many bank accounts, he may be a defaulter or he may be a fraud. Bernoulli is when you have the columns which are mostly binary, like zeros and ones. For example, gender, in case if we talk gender is male, female, or in case someone owns a house or not. So 0 or 1, whether someone owns a house, you want to predict कि उसको लोन देना या नहीं, तो 0 1 0 1 इस तरह के अगर कॉलम्स है. ओके, तो if your feature vectors are binary, right? So age is one feature and a column is nothing but, guys, a vector, right? अभी थोड़ी देर पहले मैंने आपको बताया कॉलम वेक्टर. तो फीचर वेक्टर का मतलब क्या हुआ? एक फीचर का वेक्टर मतलब एक कॉलम. तो इफ योर कॉलम्स आर बाइनरी, तो इफ योर फीचर के जो वेक्टर्स हैं, इस केस में कॉलम वेक्टर्स हैं, रो वेक्टर्स नहीं है, कॉलम वेक्टर्स कहेंगे हम. ठीक है, फीचर्स को. तो इफ योर फीचर वेक्टर्स और दी कॉलम वेक्टर्स जो है वो बाइनरी हैं 0 1, तो यू विल यूज बर्नौली. तो समटाइम्स ऐसा होता है कि आपके डेटा में सारे कॉलम जो है वो 0 1 0 1 ही है, तब तो आप बर्नौली यूज करो. लेकिन अगर आपको दिख रहा है कि मिक्स है, कि बर्नौली भी है मल्टीनोमियल भी है, you go with multinomial. Okay, or else you use Gaussian. So let's implement it. Okay, so here we are. So we talked about probability distributions in statistics, like parametric, non-parametric things, and now coming to what the model learned. The naive Bayes model, in interview they ask you, naive Bayes model learns the probabilities like likelihood, class probability, and the predictor probability, these three, so that it can predict the posterior probability. So prior मतलब जो पहले से आप निकाल रहे थे, posterior जो बाद में आपको निकालनी. Just 1 second, guys. Meanwhile, if you guys want to follow along, you can download the data from this website. I'll tell you what the data is. 1 minute. Okay, so this before we go ahead, this variation is something that you should know. This thing, that probability of this thing is given like this, right? But now how it happens is, if instead of this x, it was like x1, x2, x3, like that, right? So as I just told you, right? So yeah, so I want you to just understand how the formula finally changes is probability of c given x, where this x is all the features. So normally तो आप कहते हो कि probability of one feature with respect to class, right? But now probability of x1 with respect to this, probability of x2 with respect to this, and so on up till probability of c, and this denominator is actually vanishing here. And definitely there is a reason behind it. See, let me do one thing, 1 second. So guys, I'm just taking a screenshot. I am saving it at the place where my notebooks are, so that I can show you it here. I hope all of you are aware how to embed an image in a notebook. This is most of the time you have to do while doing the presentations. So it's exclamation, then square brackets, and then within single bracket the image name. The image should be in that place where this notebook is, at the same place. So just control enter. So ये image embed हो गई यहाँ पे. दो images हैं यहाँ पे जो embedded है, okay? अगर आप देखोगे, this is something important, okay? When you do presentations, you have to do it like this. I'm just putting it. आपकी केस में कुछ नहीं दिखाएगा क्योंकि वो images होंगी नहीं वहाँ पे. Okay. तो मैं आपको ये बताना चाह रहा हूँ यहाँ पे कि ये फॉर्मूला एक्चुअल में इस फॉर्म में कन्वर्ट हो जाता है, राइट? जब आपके पास मल्टीपल फीचर्स आ जाते हैं. अब इस फॉर्म को इस फॉर्म में कन्वर्ट कर दिया गया कि अब प्रोबेबिलिटी ऑफ x1 x2 x3 till n गिवन दिस निकालना बड़ा मुश्किल हो जाता है. तो देन उसको फर्दर एक्सप्लोर किया गया. प्रोबेबिलिटी ऑफ x1c, मतलब अगर मान लो आप लोन यस प्रेडिक्ट करना चाहते हो तो यस लोन में, और ये अगर आपका जेंडर है और ये है आपके पास से नंबर ऑफ कार्स फॉर एग्जांपल, ये है आपके पास वेदर यू स्मोक और नॉट. तो जिन लोगों को आज तक लोन दिया गया है उसमें मेल होने की कितनी प्रोबेबिलिटी है, उसमें उस बंदे के पास हाउस है या नहीं. मान लो यस हाउस है, उसकी क्या प्रोबेबिलिटी है. फिर से जिसको लोन दिया गया है वो स्मोक करता है, यस, उसकी क्या प्रोबेबिलिटी है. हमें ये प्रोबेबिलिटीज निकालनी होती हैं, इसलिए इस फॉर्म को आप कैलकुलेट नहीं कर सकते. तो इस फॉर्म को हम इस फॉर्म में एक्सप्लोड कर देते हैं और इसीलिए हम इस डिनोमिनेटर को गेट अवे कर देते हैं यहाँ से, सो एज टू कन्वर्ट. तो अल्टीमेटली दिस फॉर्म गाइस, this part is actually being exploded into this particular form. Okay, so remember this. बहुत ही minor से differences हैं, but these are important. Okay, so now since we know what the model is actually calculating, model is calculating certain likelihood probabilities based on the training data, and it will compute the future for me. So I'm just taking some simple thing. Let me take KNN. 1 second. Control F. KNN class. So I'll use two different data sets to explain you the importance of this. So I am going to create a copy, guys. File, make a copy. Okay. जब भी आपको notebook का copy बनाना है, just make a copy. So so I made a copy. Let me change its name to naive bias. This is for Gaussian data. Okay. And the another one I will tell you for multinomial data. Okay. So I have this wine data. So let me check what the wine data is. निष्ठा, the point is आपके पास वो फाइल होंगी नहीं ना. It may so happen that those files may not exist, or you can share me the command that you did. Can you share me the command that you ran? And what the warning message it's giving you? Yeah, and so guys, okay. So if you take any image, for example, just if we have to embed the image, let me do this 1 second. So just open the snipping tool. You just open the snipping tool, capture image, for example, capture this image. Make sure you save this image where your notebooks are getting saved. I'm saying sample. Give it an extension of .png or anything. Now let's just embed it. So you have to embed it. You have to convert it into markdown. Okay, Nishtha? Convert it into a markdown. It cannot be a code column. This is the syntax. That's it. Now within this bracket, you have to give capture.png, which is your file. अभी मेरे केस में भी आई नहीं. आई थिंक आपने मार्कडाउन में कन्वर्ट नहीं किया होगा निष्ठा. Okay, I gave it a name of sample. So sample नाम दिया था मैंने, तो ये मेरी इमेज यहाँ एम्बेड हो गई. Okay, तो make it markdown. Okay. Okay, guys. So what I'm looking at now is, given the data, which is 1 second. Okay. Nishtha, file extension can be any. Okay. Yeah. So that is given the data. If you see that the data is Gaussian or numerical data or the continuous numerical data, you can directly go ahead and implement this stuff. Let me run this. So here I'm simply creating the data frame so that I can do the train test split. It's fine, Nishtha, means I'll explain you. You guys can do it later. Okay. So now what we need to do here, guys, we need to use the naive bias classifier or the naive bias model, which will internally learn certain parameters, which is your probability parameters and it can further be of 3 types as we talked about. Okay, so from naive Bayes, what I can do, guys, I have multiple naive Bayes models. If you see, the most important is the multinomial naive Bayes and the Bernoulli naive Bayes and the Gaussian naive Bayes. The Gaussian naive Bayes. So I'm using which Gaussian naive Bayes? Okay. So just create an object for the Gaussian naive Bayes. No need to pass anything.
Sir.
GNB, yes.
Sir,
yes.
So we cannot see the data and presume that it will follow a Gaussian normal distribution only. So that is only after applying certain these codes that we will be able to find which multinomial will suit or which one will be exactly suitable for the data.
Yeah. So if you see on the screen, on my screen, the data that I have here, I can see that this data is categorical, is not categorical. It's like numerical data. But what you can do, if you want, you can do plot on all of these. Let me do that. Wait 1 second if you want. 1 second. So given the data, if you see that, okay, my columns are numerical, it's good. But ideally, as part of feature engineering, we have to do a lot of stuff. So I have to import Seaborn as say SNS. Okay, and what I need to do, I need to run a for loop on all the columns to plot one by one. So what I am doing here is, this is pd.data frame, right? So let me give it some name. Df equals to this, and this is my df. Now I want df alcohol. Okay. So what happens, Nishta? Yeah. So we have to do feature engineering, and as part of that, we have to do missing value checks and everything, right? As such. So what I am doing is, मेरे पास data है already. I loaded that data in the form of data frame, pd.csv, whatever way you want. Then you do is null, and then you do dot sum. So you check for the nulls, which is not there, right? If nulls are there, you do null handling. Then you do missing value imputation. Then you do scaling and new feature derivations, all those things, right? Scaling and all. But now we also do data plotting to understand the nature of the data. So let's go one by one. I'm commenting. तो अब हमारे पास दो तरीके हैं, या तो हम एक एक कॉलम के ऊपर चार्ट बनाएं, एक एक कॉलम पे बनाएं, मतलब हर एक कॉलम को इस तरह से लिखें, डीएफ अल्कोहल, मतलब ये वाइन डेटा है मेरे पास, and there is some features associated to it. And this target is a multi-class classifier here. ठीक है. So based on the quantities of certain chemicals, they have categorized wines in say 3 categories, and now given certain combination of alcohol and all those stuff, the malic acid, ash and all, I need to predict, even looking at the color of that wine, which category it belongs to, whether it's class 0, 1 and 2. So there are 3 classes to which they are dividing the wines here. Okay. Okay. So now I'm looking at my data. So for example, if this is my first column, I need to plot the normal distribution, and to plot the normal distribution, there is a density plot available in Seaborn, which we can do here. So if you know this data column, SNS dot, I'm just loading. There is something like density plot in which I have to just pass this value and it will be done. So there is this distribution plot. Let me try this first. Distribution plot. So distribution plot can help you plot all different kinds of distributions. So if you look at this, I can see that this data definitely follows this linear line, which is a bit on the linear distribution or the normal distribution, with mean around somewhere around between like 13 से थोड़ा राइट साइड पे शिफ्ट होता हुआ पीक है, तो मीन हमें इसका एक्चुअल कैलकुलेट करना पड़ेगा, बट मीन विल बी समथिंग अराउंड 12 से 14 के बीच में. So mean is 13, right? So here the data is following, मतलब somewhere around here.
Sir, but
because
how
उसके
will
दो,
we know? Sir, but how will we know
No,
that
but-
which naive-wise algo we have to use?
हाँ हाँ वही तो मैं आपको बता रहा हूँ कि if you look at your data, all of these columns are numerical, continuous numerical values. They are not like, for example, magnesium, if the value was 0 and 1, मतलब ये एक वाइन कैटेगरी, मतलब वाइन प्रेडिक्ट करनी थी, गिवन अल्कोहल इज इधर 0 और 1, मतलब या तो उसमें अल्कोहल है या नहीं है. ठीक है, 0 मीन्स नहीं है, 1 मतलब है. अगर सारा डेटा ऐसा होता 0 1 0 1 0 1 0 1 0 1, एंड देन अगर मुझे प्रेडिक्ट करना होता कि भाई ये कौन सी कैटेगरी ऑफ वाइन है, तो मैं बर्नौली नाइफ बेस यूज करता, क्योंकि वहां मुझे अल्कोहल की क्वांटिटी नहीं पता होती, ये पता होता है अल्कोहल है या नहीं. अगर एक वाइन में अल्कोहल है तो वो इस टाइप की है, अगर नहीं है तो वो इस टाइप की है. 0 1 0 1 दैट्स इट. तो आप बर्नौली यूज करते. लेकिन अगर आपको ये दिया गया है कि अल्कोहल की क्वांटिटी, yes go ahead.
Sir, so for continuous only Gaussian is there?
Yes. So for if the data is continuous, it is Gaussian. If it is binary, it is Bernoulli. If it is ordinal categorical, like 1 2 3 4 5 6 like that, then it is multinomial. But I have seen that on Bernoulli data I applied multinomial, it worked. On multinomial I applied Bernoulli, it worked. But accuracy में थोड़ा इधर उधर का फर्क था. However, I just checked कि वो break होता है कि नहीं, तो वो fail नहीं हुआ. Long back I checked it, but ideally you should not use it, right? कोई चीज break नहीं हो रही, मतलब वो internally उसको किसी तरह handle कर रही है. But why you want to handle something when you already know the best alternative? Okay. One second. One second, please. Hello. Yeah, sorry guys. Okay. Yes. So this is how you have to first of all check whether your data is categorical, numerical, and then which model to apply in naive Bayes. And further, you can see whether your data follows the Gaussian distribution or not. If it does not follow, you can apply scaling like the min-max scaling or the standard scaling to bring it in a better shape. As compared to this, it will be in some better shape. So you can do that. Now the another point, one second. The another point that I was saying here is, instead of plotting this model one by one, is there a way I can directly run a for loop? Absolutely, I can do that. That is very simple. What you have to do, you have to simply use this few programming skills where you say df.columns, you get all the columns, right? Just cut it off and say for I in this, okay, let me print I, okay. So you get all the columns, perfect, very good. Copy this stuff, put it here within the loop, and now instead of this thing alcohol, put in I here. One second. No? Okay, I have to import this. Yeah, so programmatically we do everything, okay, in the projects, because you don't know today आज आपके पास 10 कॉलम है, तो आप किसी तरह से 10 कॉलम को यहाँ पे 10 बार लिख भी दोगे, right? मतलब you can keep typing this 10 times, but tomorrow if the column name changes, for example, then this will fail, right? So you don't want such problems to happen. So we never hard code our programs. So what we do in this, अगर आपकी फाइल में कोई कॉलम का नाम भी चेंज हो जाए या नए कॉलम भी ऐड हो जाए, मुझे कोई प्रॉब्लम नहीं है. For I in df.columns, I am printing the column name, or you can print it like in much better way. Plot for feature this is this, like that. So plot for feature alcohol is this, plot for feature malic acid is this. So whenever I have to do feature engineering, it takes 1 to 2 days, okay. इस तरह के सारे प्लॉट्स लूप्स बनाने होते हैं मुझे, ठीक है. कम से कम 1 दिन लगता है सिर्फ फीचर इंजीनियरिंग के प्लॉट्स बनाने में, सारे सोचने में. आप यहाँ देखोगे तो यहाँ इमीडिएटली आप देख सकते हो कि भाई आपका सारा डेटा एक तरह का नॉर्मल डिस्ट्रीब्यूटेड प्लॉट्स को फॉलो कर रहा है. स्टैंडर्ड डिस्ट्रीब्यूशन नहीं है, बट नॉर्मल डिस्ट्रीब्यूशन है. कैटेगोरिकल डेटा नहीं है इसमें कोई भी. कैटेगोरिकल डेटा पे वो प्लॉट ही नहीं करता. अगर कैटेगोरिकल डेटा होता तो डिस्ट प्लॉट ही नहीं करता उसको, या उसको किसी अलग तरह से प्लॉट करता, तो मुझे देखते ही पता लग जाता. तो फिर मैं क्या करता हूँ, इफ आई नो दैट माई डेटा कैन कंटेन कैटेगोरिकल थिंग, आई पुट दिस इफ. अभी मैं वो लिख नहीं रहा हूँ प्रोग्राम, आपको सिर्फ लॉजिक बता रहा हूँ. इफ df डॉट, मान लो जो भी आयत कॉलम है, डॉट उसका टाइप या उसका डी टाइप, डेटा टाइप, आई से इक्वल टू इंट, तब तो आप एसएनएस प्लॉट करोगे, ओके. अभी तब तो आप एसएनएस प्लॉट करोगे. अगर वो कैटेगोरिकल है तो मैं कौन सा प्लॉट करता हूं गाइस, एनीवन? एसएनएस डॉट वैल्यू प्लॉट. हमारे पास वैल्यू प्लॉट होता है. अगर कैटेगोरिकल डेटा है तो वी डू वैल्यू प्लॉट्स. तो बेस्ड ऑन द डेटा टाइप, सो दैट आई कैन अवॉइड द एरर्स. कि कल को मेरे डेटा में अगर कैटेगोरिकल कॉलम्स आ गए, आई वांट दैट टू बी अवॉइडेड. So I can do that also using if then else. इफ यू वांट अभी के लिए हम दोनों ही प्लॉट कर सकते हैं यहाँ पे। मैं न्यूमेरिकल पे भी चला सकता हूँ, ऐसा कुछ नहीं है। वैल्यू प्लॉट, okay, so there is this count plot. So there is this value plot or the count plot, which can also be done. But numerical data पे count plot it's taking some time, but yeah, make sure when you are submitting your notebooks to anyone, you have all the plots and feature engineering and everything done accordingly. And instead of hard coding, everything needs to be done programmatically. Okay. So I'm pinging you these commands, guys. Please follow along. I'm pinging you this. Please follow along. I'm using a data set which is already there in sklearn, which is the wine data for categorical predictions. You can convert this data into the data frame because normally वो array की form में रहता है. हाँ, एक नई नोटबुक बना लो आप लोग, उसमें ये जो मैं पिंग कर रहा हूँ टाइप करते चले जाओ एंड ये प्लॉट तक प्लॉट कर लो. So it is still plotting it, but this is what I am saying कि categorical data में count plot makes sense, but in numerical data it does not make sense, right? Because हर एक numerical value उसके लिए एक independent value है, उसके count कितनी आ रही है, हो सकता है थोड़ी ज्यादा बार आ गई हो, but count plots should only be used for categorical, not for numerical. For numerical you use dist plot or distribution plot. So we'll take a break here for 15 minutes. We'll connect at 12 o'clock. Till that time, please plot the models, all these models. Model means the chart that I'm saying. And when we are back, we will implement the model. Yes, tell me.
So that PD.data frame code that has been left, we have to do it on ourselves?
What?
So the code in which you have converted this to a data frame, we have to do that.
Everything, I have pinged you everything, ना? ये सब कुछ सब आपको करना है ना?
No, sir, not the code.
ये?
Not the, yeah, not, हाँ.
मैंने सब पिंग किया है, आप देखो उसमें ऊपर चाहे ऊपर चला गया होगा. आपको डेटा फ्रेम में तो हमेशा कन्वर्ट करना ही होता है ना. So do everything. PD.data frame, pass on the data, feature names, right? Pass on everything, and then do the plots, use the for loop, then do the split, and then once you are done with the split, yeah. So once you are done with the split, just import this model. Go through this model and then we will talk. Okay, after 15 minutes, guys, we will start this. Yeah, hi guys, I'm back. So did everyone ran till this place? Uh, Guys, am I audible? Yeah, perfect. Okay. So if you have seen the hyperparameters, it's good. If not, let's see some of the hyperparameters. So see, hyperparameters, as I told you, is something that you tune, okay? And parameters is something that model learns. So where the parametric, non-parametric debate comes in. So just know the difference, hyperparameters and parameters. Okay, so now this model, as such, you don't need to pass much of the things. So the only thing is, if you already know the prior probabilities, you can pass those, but we don't want to fix any prior probability. We want model to calculate it from the data. So हम हमारी जो प्रायर प्रोबेबिलिटीज हैं मॉडल्स को वैल्यू पास नहीं करने वाले, हम ट्रेनिंग डेटा से ही बोलेंगे उसे कि कैलकुलेट कर लो इसको. सो दैट्स द ओनली थिंग. आप प्रायर प्रोबेबिलिटीज खुद की भी फिक्स कर सकते हो अगर आपको पता है. ओके. The output of this model is definitely the classes, or rather the class priority, which is the probability of each class, which is something that this model is actually learning. Okay. Class count, it's all those parameters which are used to calculate the probabilities. If you try to dig deeper, like what is the probability of each class, and then for each class, how many observations are there, how many classes are there. Okay, so these are some of the important parameters. Again, per feature, per class, variance and mean, internally to the formulae, these things will be calculated. So you don't need to change any hyperparameters as such here. So you don't need to do any changes. Model will learn on its own. So let me just cancel it out. Okay. So now, and this is the output that we got. Other than that, let's see what else this model offers. So if you look at it, so what's happening here is, जो भी डेटा आपको दिया गया था, ट्रेनिंग डेटा, जिस पे मॉडल रन किया आपने, फिट किया, मॉडल आइडेंटिफाइज दैट देयर आर 3 क्लासेस, 3 class classification, and our probability for the classes is 31, 40 and 28, which itself says that probability of class 1 is highest in the given data. Okay. So what I mean here is, yeah. So if you go back to this, so this is what I am showing you, the class probability for each class, which model learns. This anyways we don't use. And this is another thing, which is for each class, like say for class Y, what is the probability of a particular feature? So per feature, so like this, per feature probabilities are also calculated. One second, I'm just putting predictions later. So this is important, the class probabilities that you can check here. So these are the classes. So how many classes are there? What is their prior probability? Okay, so go through this. We will see. So go through this in detail, all these things which are coming as output. The important thing is once you fit the model, you have to simply predict it. This is the predicted output. After that, you have to check its accuracy, which is the test accuracy. But before that, let me check the train accuracy. So it's 97.5. So if we fit this model and we check the accuracy of the train, it's 97.5. Now we have to check the final accuracy of the model. It is coming out to be 98. So if you look at this model, the benefits of naive Bayes model is A, it is very fast because there is no complex logic of gradient descent or convergence as such. It's simple calculation of probabilities, so it's very, very fast. The drawbacks are that in real world, this may not really be a good fit because of the ignorance of the multicollinearity. Okay. However, it has been seen that naive Bayes works good even if it's ignoring the multicollinearity, but still it's not a recommended model as such. But where is it recommended is in the field of natural language processing, the another example that we are going to look. So whenever you have documents and you have to classify those documents as say belonging to healthcare domain or financial domain, you use it, but not for the feature data like the one we have in this case. Though it shows you very high accuracy, it may not be a good model for production level. Okay. So this model is giving 98% accuracy. However, it depends on again the data, the features, and the records. Can anyone tell me, like, if a model is underfit, like what do you normally do to avoid the underfit? I know this have been discussed multiple times, but this is important. If I give you a data and your model comes out to be underfit, what you normally do? Yeah, Vipul, more data, but that don't helps always. See, more data only helps when we say that the current data does not capture the variance, the data variance, but so if it's underfitting, Aditi, we do feature engineering, but how we do that? So the point is, when the model is underfit, we try, our focus is to make it overfit. Okay, think like that. Someone is overfit. What you can do to make it, someone is underfit, how can you overfit it? Think in that direction. तो कोई चीज ओवरफिट कब होती है? जब ज्यादा से ज्यादा फीचर्स हो. ओके, कोई चीज ओवरफिट कब होती है? जब ज्यादा से ज्यादा फीचर्स हो. सो दैट मीन्स अगर किसी अंडरफिट मॉडल को बेटर करना है, you can ask for more features. Rather, when we say more data, we don't say more records. Rather, we should say more features. Okay, because it may so happen that the current data does not capture all the features. So this is important. So when a model is underfit, you ask for more data, but in terms of features rather than in terms of records. Definitely in terms of records also you will ask, but majorly it's in terms of features. And the second thing is, if someone cannot give you more features, you try to create your own features. Okay, that's where feature engineering is. And when you create your own features, try to create the features of polynomial degree, like x square, x cube, because that's where a model tries to overfit, right? If you guys have read about it, right? Mostly overfit is model is the one where the features have a polynomial degree. So if something is underfit, you can ask for more features or create your own features, or you can create features of the polynomial degree. Okay, so remember this. So if someone asks you this in interview and you say we need more data, that is a very vague term. You need more data in terms of features, like you, or in terms of records. So be specific on that. And then the question that comes is how that thing will help. Okay, so remember this. Yeah, so ultimately we don't overfit the model, but I'm saying something is underfit, so you ask person who is overfit, भाई तो overfit कैसे हुआ था बताइयो, तो so that जो underfit है मैं उसकी help कर सकूं और एक common ground पे आ सकूं. So that's what it is, right? Over successful people may help the people who want to succeed, like that. Okay. So yeah, so it's all the optimization strategies that we are talking about. So there is something known as bias variance trade-off when we talk about underfitting and overfitting. Like when we talk about underfitting and overfitting, there is a curve like this, and then there is this sweet point. So there is this bias variance trade-off curve. Bias and variance both are the errors. We want to decrease both. So there is a sweet point where we come. Okay, it's like if I increase the complexity of the model and say this is my error, if I'm increasing the complexity of the model, what will happen? The model will tend to overfit. So this line, it's going from here to here. Like here you have underfit, here you have overfit. So you're moving from underfit situation to overfit situation as you keep complicating your model. Okay, so if you keep complicating the model, if you start using complicated models, chances of overfitting increases. Okay, overfitting increases का मतलब क्या है कि your training error decreases, right? So this curve is saying the training errors are decreasing, right? So if you increase more complex model, or if you keep increasing the features, a model becomes more complex. So you move from underfit to overfit, your training error will decrease, but your test error will keep increasing. Understand this. Your test error will keep increasing. So you need a sweet where you can say this is the उसके ऊपर sweet point where my bias variance are आप एक को बढ़ाने जाते the bias variance trade off. I am saying it's where it's optimized. Questions आते हैं written exam This is optimized, definitely. This is good. The narrower the gap, the better it is. However, if this would have been like this, and this would have been like this, if I would have compared this one with this one, if this one with this one, say this is X and this is Y, which one is better, guys? X or Y? In both, they are reaching a sweet point, but is X better or Y better? Perfect. Thing is, both the errors are quite high. Both the errors are quite high, whether it's train error or test error, right? So these things comes in interviews. You have to interpret it. So reaching the sweet point is good, but in this case, both may give you 90% accuracy, but in this case, both may give you 70% accuracy. So this may not be good, though they are reaching a sweet point. Coming to this, how will you interpret it? Increasing the complexity, error is going down, right? So increasing the complexity, error is going down. So at this point, if there is complexity, error has drastically reduced. So what I would say, at least increasing the complexity, my error is decreasing. It may be overfit or it may be a good model. Let's see. Here, increasing the complexity, the test error is increasing, but not very drastically. It's just very minimal up to this. Okay, say only 1% is error, 99% is good. So your test accuracy is also quite good. Okay, so test accuracy is good, it's not bad. Okay, so it's not going underfit. Okay, it's not going underfit because test errors are not very high. If test errors are also very high, it would have been underfit. For example, if this is here and definitely there is gap, but if say for example your test errors were also increasing quite, like if I have to compare this, X with this as Y, है Y वाले केस में आई कैन बिकॉज मेरा बहुत ज्यादा है. ओके, डेफिनेटली मैं इस वाले एरर को भी देखूंगा कि यहाँ पे वैल्यू क्या है. सो यू अंडरस्टैंड कि व्हेनेवर देयर इज गैप यू कैन नॉट से ब्लाइंडली वेदर इट इज ओवरफिट और चेक इज यू हैव टू चेक फॉर बोथ. कि मैंने कोई स्केलिंग नहीं की है, यू कैन फर्दर से कि वो अंडरफिट है ओवरफिट है. कि ट्रेन डेटा में अगर बढ़ रही है तो मैं कह सकता हूँ कि ये मॉडल्स ज्यादा है तो मैं कह सकता हूँ अंडरफिट है. ठीक है, तो दे कैन गिव यू सच काइंड ऑफ क्वेश्चंस. सो रीड अबाउट कंफ्यूजन मैट्रिक्स वगैरह बना सकते हैं. या बट इन दिस केस we are not having Gaussian data or the numerical continuous data. Rather, we have the kind of ordinal categorical, okay, or maybe discrete values. So if you have ordinal categorical, you can convert it using scaling, ordinal scaling. 1 second. Okay. ओके, सो नाउ यहाँ पे हमारी प्रॉब्लम स्टेटमेंट ये है कि आपको अगर कोई मैसेज आता है दिन में, तो वो मैसेज एक फेक मैसेज है या सही मैसेज है, एक एसएमएस। सिमिलरली यही काम आप ईमेल भी कर सकते हो कि अगर आपको एक ईमेल आता है तो वो ईमेल वैलिड है या इनवैलिड, मतलब एज इन फेक है, स्पैम है नहीं, तो वहां हमें थोड़ा टेक्स्ट एनालिसिस करना होता है। सो लेट्स टॉक अबाउट दिस. So here the data that I am taking is from the UCI website. There is some SMS data. So I took that data. I downloaded their file. They give you a compressed file. You can download it. And then I show you this is how that data looks like. So there the data is like the target and the message. Okay. So what happens here is you have only two columns, the feature and the target. But we cannot run a classification model blindly on this kind of data. So what we need to do is we need to convert it into features. So that's where text analytics comes into picture. Yeah. Yes?
So this file is not so this file is not CSV, so it's not even showing the extension, so it's a JSON file format.
No. Even if a file is not showing you the extension, I told you, right? I think आपकी क्लास में बताया था कि extensions does not matter. Extensions only matter when we talk about a specific tool that understands that extension. But pandas like can open this file. This can still be a CSV file, means comma separated file, though it's not .csv. It can be a .txt also, but उसके अंदर डेटा जो होगा it will be like A, B, C, like that. That's not a problem. But उस चीज को आपको हाँ ब्लाइंडली नहीं रिलाई करना है, आपको फाइल खोल के देखनी है कि आपकी फाइल क्या है. ये है मेरे पास फाइल, राइट? दिस इज माई फाइल, राइट? तो आप देखोगे तो ये फाइल है, इसका एक्सटेंशन कुछ भी हो मुझे उससे कोई फर्क नहीं पड़ता, बिकॉज ये डेटा फाइल है. मैं नोटपैड में खोलता हूँ इसे. अब नोटपैड में अगर मैं इसको ओपन कर रहा हूँ तो यहाँ पर आई कैन सी कि ये कॉमा सेपरेटेड तो नहीं है, बट ये हो सकती थी, कोई प्रॉब्लम नहीं थी. लेकिन यहाँ पर हर एक वैल्यू के बीच में कुछ स्पेसेस है, राइट? दिस इज अ स्पेस सेपरेटेड फाइल. बट अब प्रॉब्लम ये हो जाती है कि ये तो आपका पहला कॉलम है और ये आपका दूसरा कॉलम है. अगर मैं स्पेस के बेसिस पे इसको सेपरेट कर दूंगा तो ये वैल्यू अलग हो जाएगी, ये अलग हो जाएगी, ये अलग हो जाएगी, राइट? जबकि मुझे इसको एक साइड रखना है, इसको एक साइड रखना है. तो आई सॉ जहां से ये फाइल आप डाउनलोड करोगे दैट इन दोनों के बीच में जो स्पेस है वो टैब है. इट्स अ टैब सेपरेटेड फाइल, टैब. जबकि ये सारे आपके नॉर्मल स्पेसेस है, तो इट्स अ टैब सेपरेटेड फाइल. Okay, it's a tab separated file. So whenever you have a tab separated file, you simply have to specify this separator as tab. This \t is meant for tab. Okay, if it's comma, I think it's a 00. The value is something like \001, something like that. This indicates the space. Okay, there are other indicators also, like \s can be for space, \001 can also be for space. It depends from language to language. तो ये आपका टैब है. कॉमा सेपरेटेड होते तो आप यहाँ कॉमा लिख देते, राइट? तो ये बस आपको हमेशा फाइल ओपन करके पहले देखनी है. आप यहाँ पे इसको रीड CSV से भी रीड करके देख सकते हो. लेट मी ट्राई. Pandas has no attribute CSV. Oh, sorry. देख रहे हो, मैं उसे CSV से भी रीड कर सकता हूँ. पहली बात, ये extensions does not matter. Extensions only helps us to immediately know what the file will be. But if there is no extension, you have to open the file or go to the source team to ask भाई इसका सेपरेटर क्या है. तो अगर इसका सेपरेटर टैब सेपरेटेड है तो CSV फाइल से भी आप रीड कर सकते हो, मतलब CSV से भी, जस्ट स्पेसिफाई हेडर, लेबल एंड एवरीथिंग. सो बोथ रीड टेबल इज अनदर वे, लाइक रीड XLX, बहुत सारे तरीके हैं. तो मैंने इसको रीड कर लिया, ये मेरे पास डेटा आ गया. अब मेरा पर्पस ये है कि इस कॉलम को फीचर्स में कन्वर्ट करना. तो फीचर्स में कन्वर्ट करने से पहले ये जो वैल्यू है लेबल्स, इनको भी 0101 में कन्वर्ट करना है, राइट? तो this is the label column, and then I am applying the map function, and in the map function I am passing a dictionary of key value. So wherever you find key, replace it with this value. Wherever you pass this, find this, replace with this. It's like you have map function, filter function, reduce function, right? In Python, map, filter, reduce. So this is what map function will do, and as soon as I run this, my labels are being converted into 0 1s. Okay, now what is left is only the pre-processing of the message column to convert it into multiple columns like x1, x2, x3, and here what will be those columns, guys? See, मैं कब कहूंगा कि एक जो मैसेज है वो स्पैम है? जब उसमें ऐसा होगा कि उसमें पैसे की बात हो रही हो, या उसमें बोल रहा हो क्लिक क्लिक, बहुत सारे क्लिक लिंक्स हो, तो मैं कह रहा हूं, जबकि अदरवाइज मैं कह सकता हूं स्पैम नहीं है. तो अगर मेरा x1 है कि मनी वर्ड कितनी बार आ रहा है, दिस इज द वर्ड मनी, एंड द वैल्यू इज कि उस मैसेज में वो वर्ड कितनी बार आया. मान लो 10 बार आया, दूसरे मैसेज में वो सिर्फ एक ही बार आया. सिमिलरली दूसरा फीचर हो सकता है क्लिक. क्लिक जो वर्ड है वो उसकी फ्रीक्वेंसी क्या है, फ्रीक्वेंसी इन दैट मैसेज और डॉक्यूमेंट. मान लो क्लिक करने को उसने यहाँ पे 5, उसने क्लिक करने को बोला ही नहीं है. तो अब मैं ये कह सकता हूं कि व्हाट इज द प्रोबेबिलिटी ऑफ स्पैम गिवन it contains the word click and the word money. So what is the probability of spam given it contains the word money or click? What will be the formula? It will be the probability of word money in the spams multiplied by probability of word C in the spams multiplied by the total probability of spams. मतलब अगर मुझे दिन में 1000 ईमेल आते हैं, उनमें से कितने स्पैम होते हैं, उसकी प्रोबेबिलिटी. तो ये फॉर्मूला है बस, दैट्स इट. तो ये मुझे निकालना है, पोस्टीरियर है, और ये मेरे यहाँ पर लाइक्लीहुड्स हैं, और ये मेरी प्रायर प्रोबेबिलिटी है. तो अल्टीमेटली आई हैव टू प्रोसेस दिस डेटा in a way that I will get the features like the words and the values like counts. So now if you see, हर वर्ड का काउंट एक डिस्क्रीट वैल्यू होगी. अगर डिस्क्रीट वैल्यू है तो मैं गॉसियन डिस्ट्रीब्यूशन नहीं लगा सकता. That means either I will use binomial or I will use multinomial. बाइनोमियल भी यूज करने का कोई पॉइंट नहीं है, क्योंकि 0101 नहीं है. 01 मतलब कि क्लिक वर्ड है या नहीं, मनी वर्ड है या नहीं, 010101. बट यहां पर उनकी एग्जैक्ट वैल्यू है. ठीक है. अब क्योंकि फीचर इंजीनियरिंग मैं कर रहा हूं, तो मुझ पर डिपेंड करता है कि ये फीचर मैं कैसा बनाना चाहता हूं. मैं चाहे तो इन फीचर में 0101 कर सकता हूं, जस्ट एग्जिस्ट डज नॉट एग्जिस्ट वाला, या फिर मैं एक्चुअल काउंट निकाल सकता हूं. एक्चुअल काउंट मेक्स मोर सेंस हियर, right? Because money word can be in a genuine SMS also, but if more times he's talking about money, then it means that it's a fraud. So इसलिए 0101 will not help me, rather the exact count will help me. So that's why when I am creating the feature, I will calculate the frequency of a word rather than 0 or 1. समझ आ रहा है कि जो मैं फीचर इंजीनियरिंग करके नया फीचर बनाऊंगा, उसमें मैं 01 भी रख सकता हूं, उसमें मैं frequency भी रख सकता हूँ, लेकिन 01 is not the right indicator because genuine messages can also contain word, money or click. But the ones which contains more of words like this have more chances of spam. The ones which contains lesser of these have lesser chances of spam. So I am creating a multinomial kind of data. So I will apply multinomial distribution or multinomial naive bias. Okay. Okay. So let's proceed ahead. What we are doing on this data, let's see. Okay. First of all, converting the entire data into the lower case, because if we don't do that, then small click and upper click both will be different words. So whenever we are doing text analytics, so guys, we are talking about here today your text analytics or the natural language processing also in parallel. Okay, so this is your natural language processing. Natural language processing is like you are processing the text data when processing or the audio data. So this is what is NLP. Okay. So first of all, we converted everything like lowercase. Each, what are they? They are your punctuations. No, not spaces, Fatima. Because space हटा दूंगा तो ये सब आपस में ही एक ही वर्ड बन जाएगा. You don't do that. Rather, your punctuation marks will be removed. Punctuation marks as in this thing, this star, this comma. Spaces you should not remove, like white spaces you should not remove. Rest everything we will remove. So in this message is this thing. Stop words. And okay, so there are a whole lot of concepts of the verbs, nouns, pronouns, adjectives, and all that we handle as part of. There is something known as part of speech, POS. So what is it? If I am saying go until Jurong Point crazy available only in, for example. So we do part of speech pause tagging, guys. Okay, remember this. POS tags or POS tagging. Matlab, if I am saying I don't think, so I is a noun or rather a pronoun, right? So this is what part of the speech? Noun or a pronoun. Think is what? Is like an action that you are doing, which is a verb, right? Don't, it is what the helper words that comes along with maybe adjectives, verbs, or anything. Like if you say fast, then fast is an adjective, but very fast is like making that adjective more putting more strength on it. So it's a helper word like that. So we do whole lot of English grammar analysis. We do part of speech tagging, and then we remove certain kind of words from our entire sentence. Yes. Any question? Okay. Okay. So now to do all these things, guys, pause tagging, part of speech tagging, like identifying कि उस पूरे sentence में verbs कौन से हैं, nouns कौन से हैं, pronouns कौन से हैं. We need a package which is known as NLTK, Natural Language Toolkit. Okay, so you have to import this package. I will tell you. Wait 1 second. Huh? But in NLP, there are some important things to know. One is pause tagging, another is known as stemming. Okay, stemming. So देखो, सबसे पहले आपको कभी भी कोई टेक्स्ट या सेंटेंस दिया गया है, उसको लोअर केस में कन्वर्ट कर दो, उसमें से पंक्चुएशन हटा दो, उसमें से बैड वर्ड्स या स्टॉप वर्ड्स अगर हटाने हैं तो हटा दो, बट वो डिपेंड करता है आप किस तरह का एनालिसिस करना चाहते हो. बैड वर्ड मतलब होता है ना कि मतलब कुछ वर्ड्स विच आर नॉट गुड, डेरोगेटरी टाइप्स. Yeah. So, and then we do actual NLP, which is pause tagging and stemming. So, pause tagging we talked about. Stemming is what? Stemming is, yeah, Tanya, you are correct. Stemming is like you are, like you have a tree and say it has a lot of stems. You want to cut the stems, okay, or branches, so that you only have the root or the original thing available. Means go is the root word. It can be going, goes, gone. तो क्या ये सारे वर्ड में अलग अलग ट्रीट करूं? नहीं, मेरे लिए ये और ये दोनों वर्ड सेम होने चाहिए in the field of NLP. So I want to cut the stem, the additional part, to reach to the root word. So that's what Tanya is also saying. Playing can be like play. You remove the additional part, which is not required here, which may be related to even past tense, present tense, whatever. You remove all those stuff, so that's the stemming. And then there are specific algorithms to do stemming. We will talk about something known as Porter stemmer, P-O-R-T-E-R, Porter. The Porter, we will talk about Porter stemmer. Then there is another thing which is known as lemmatization. Lemmatization, which is similar to stemming. Lemmatization. Okay, we do lemmatization, which is, we'll talk about that later. You guys can read meanwhile. So in the field of NLP, you take the word, convert it to uppercase or lowercase, either one. Remove all the punctuations, bad words, stop words, do the pause tagging, do the stemming, do the lemmatization, and you are ready to implement the model. So keeping these things in mind, let's proceed ahead. So what we have to do now, we have to use the NLTK package. So just import this NLTK package. It is quite heavy, so may take time. It opens a window. Stop words, Gulzar, means किसी को जैसे बैड वर्ड्स बोलना, किसी के बारे में गालियां वालियां होती हैं, तो आप उन चीजों को हटाना चाहते हो, जैसे बैड वर्ड्स हो गए, या फिर जैसे मैं कह रहा हूँ ए एन द, इस तरह के वर्ड्स. तो स्टॉप वर्ड्स हो गए जैसे ए एन द, फिर आपके कुछ बैड वर्ड्स हो गए उसमें, ठीक है, डेरोगेटरी वर्ड्स टाइप. हाँ निष्ठा, तो अब आप लोगों को क्या करना है, जब आप इंपोर्ट एनएलटीके कर लोगे तो पहली बार में आपको ये चलाना है, nltk.download. You'd only do once, okay? It opens a window. See, it will open a browser window. Here it is. Now, natural language is processing is a very big word, okay? Like Alexa and all those kind of things. So you have to see कि मुझे कौन सा पैकेज जरूरत है. For my particular working. So collections gives you all the books, corpora, like you need Harry Potter kind of books, it will download you those books if they are not proprietary, they're open sourced. Okay, so because आपको NLP करना है लेकिन आपके पास डेटा ही नहीं है, तो आप यहाँ से ये पूरा उनका कॉर्पस पूरा डाउनलोड कर सकते हो, अवेलेबल. Anishta, NLP and text analytics is same. Natural language processing is a very big world. Text analytics is a part of it. Audio analytics is another part of it. So whenever it's natural language can be in the spoken words like audio. It can be in the written, which can be like text. So NLP is natural language processing. It can be audio, text, like that. Even you talk to Alexa and all, right? So NLP, specifically the audio analytics. But each audio analytics internally uses text analytics as well, because audio first gets converted into text and text first converted into audio. Okay. या गुलजार, ऑडियो एनालिटिक्स का बहुत ही स्मॉल पार्ट होता है वॉइस रिकॉग्निशन. वॉइस रिकॉग्निशन इज अ वेरी स्मॉल पार्ट ऑफ इट. ओके, ऑडियो एनालिटिक्स इज अ वेरी बिग फील्ड. ओके, फॉर एग्जांपल speech synthesis. I am speaking in a particular language, it gets converted into another language, like translation. I am speaking in a male voice, but it converts it into a female voice. All these are audio analytics. Or just by listening to the voice, your model can predict whether it's a male voice or a female voice. Okay, so it's not only that it's your voice or other person's voice, you can think about multiple use cases. Okay, so voice recognition is normally when you want to open a door that only you can open. So that's where it's like, it used to be there in like Alibaba Chalice Chor types, Khulja Simpson. That was also like voice analytics. Okay, it's only understand certain words or certain voices, then it's voice analytics, but audio analytics is far bigger than that. Okay, so there are a lot of data, guys. This WordNet data is the most famous data. You want to do Twitter analytics, you have Twitter data. There are a lot of data available. And then these are all the models which are available. We need, guys, is we need stemming. We need to do 1 second. Yeah, Nishtha, NLTK packages for NLP only. Natural language toolkit can do most of the NLP, whether it's text analytics, it cannot do everything. There are advanced packages also, but this is the most important package in the field of NLP. Without deep learning, if you talk without deep learning, this is the most important package. So stemming, you are using the Porter stemmer, right? You are using tokenization, word tokenization, so all these things, right? So let me check these, what all I need. नहीं नहीं, आपको इसी विंडो से डाउनलोड करना है जो मेरी स्क्रीन पे दिख रही है. आप लोगों की केस में भी ये विंडो खुली होगी. आपको यहीं से ही सब चीजें डाउनलोड करनी है. I'm downloading this PUNKT. This is Punket tokenizer. Then word to vector. If you have to do Spanish analysis, you can have Spanish things. This is Porter stemmers. This is out of date, so it's not getting installed, which is fine. So guys, please do it parallelly. You can download this Punket tokenizer, word to vector, snowball data. Okay, this Porter stemmer. There are other stemmers also, like RSLP stemmer. You can download as many as you want. There is no such limit. Sentiment analysis. This is also very good package. Bother sentiment. Moses and all. So just download this, but while you're downloading it, read about it, what it's saying. So you can download more than one, that's perfectly fine. Okay, so I have downloaded a few. So as and when you get an error, you can download that package. You can open this and download that. But yeah, make sure you comment it out. It's fine, it's fine. It will take some time. It's fine. See guys, now what I did on this data, I need to split it into columns, right? That each sentence I need to split it into columns or split it into words, correct? So I have to do tokenization. So tokenization is the process of splitting a sentence into multiple words. Okay. नहीं वो पॉपअप विंडो ना कई बार खुल जाता है साइड में, तो अपना एक बार कंट्रोल पैनल खोल के देख लेना. I have opened somewhere. So open the task manager. You can open the task manager here and can check कि वो खुला होगा कहीं ना कहीं. Yeah. Okay. वो कई बार खुल जाता है, हमें दिखता नहीं है साइड में. हाँ. ओके. तो अब हमने वर्ड टोकनाइज कर दिया. आप देखोगे तो हर एक जो सेंटेंस है NLT के organizer splitted every sentence into words. Now each word, what you need to do stemming, right? Like joking should convert to joke. Similarly, going should convert to go. So Porter stemmer I am bringing in, creating an object of Porter stemmer. I am just applying this thing. I am saying stemmer.stem. Each word in the sentence or that array, rather that array, I am stemming it. So if you see, it has become go, right? Joke, right? Similarly, other words might have also been converted, like bitch is for bitching, right? That's how it works. Further, if we are not satisfied with the stemming, we can do second step, which is lemmatization, but it's not always needed. So I did Porter stemmer. Porter stemmer use करके मैंने अप्लाई फंक्शन, आप लोगों ने जैसे आर में भी सुना होगा, एल अप्लाई, आर अप्लाई, एस अप्लाई, अलग अलग अप्लाई फंक्शंस होते हैं. तो अप्लाई फंक्शन क्या करता है, इस एरे के हर एक एलिमेंट पे लगेगा, इस पे भी लगेगा, इस पे भी लगेगा, इस पे भी, मतलब एलिमेंट बाय एलिमेंट ऑपरेशन. इंस्टेड ऑफ डूइंग एन ऑपरेशन ऑन द एंटायर एरे, you want to do an operation on each element of the array, so you apply the apply function or maybe map function also. आप map function भी try कर सकते हो. And then I am doing the lambda. आप lambda function use कर सकते हो, तो खुद का function बना सकते हो. तो it's saying lambda function x such that you apply this for y in x. Means for every element in x, which is, you can say I, you can also say I, you want to stem the I. So for every element in array x, where this x actually denotes every element of this. So you can do this. So after tokenization, stemming is done. Yeah, and ignore that. Means for the time being, it may take time depending on your network bandwidth and all. You can ignore that for the time being and do it after the class. So guys, now if you see what happened is total number of messages SMS I have 5572, right? 5572, and finally I converted it into the format which I wanted, which is this. This is my final data. Not talking about these two. I will talk about these later because ये ज़्यादा हो जाएगा unnecessarily. ये सारी कोड्स मैंने वहाँ डाल रखेंगे तब पे. Okay, you can take it from there. With the name of naive bias, you will get it. ये दोनों मैं अभी नहीं बता रहा. जब हम NLP की बात करेंगे तब बताएंगे. It will be too much. Just remember that once we reached to this step, now what I need to do is I need to create a data frame where this is one column, this is another column, this is another, this is another. All of these are columns, right? So जितने भी total words हैं, that many columns will be created. ऐसा नहीं है कि इसमें जितने words हैं उतने column. Total जितने भी words हैं वो मेरे columns बनेंगे. तो total words पूरे इस data set में 8145 हैं across SMSs. टोटल सब वर्ड्स मिला के 8145 है. तो मान लो अगर ये आपका, मैं यहां समझाता हूं. मान लो ये आपका मैसेज M1 है, ये मैसेज M2 है. इसमें वर्ड है A एंड B और इसमें वर्ड है A एंड C. ओके ओके गाइस. सो जो आपको नया डेटा बनेगा, जो हम बनाने की कोशिश कर रहे हैं, ये तो क्या है, मैसेज और ये मतलब उसका कंटेंट है, दो वर्ड्स उसके अंदर, राइट? इस तरह से मान लो. और इसको ऐसे कर देते हैं, हेलो राहुल, और इसके अंदर है बाय राहुल. ओके, ये आपका ओरिजिनल मैसेज था, राइट? लेकिन अब जो नया डेटा सेट बनेगा आफ्टर ऑल दिस NLP विल बी M1, M2, hello as one column, Rahul as another column, by as another column. मतलब 3 कॉलम बनेंगे गाइस. आई होप दिस इज क्लियर, राइट? कि 2 वर्ड्स यहाँ के भी हैं और यहाँ पर एक एक्स्ट्रा वर्ड भी है. अब यहाँ पर होता है बाय राहुल meet you tomorrow. So total words will be, मतलब new columns will be meet you tomorrow, right? और यहाँ पर मैसेज होता है M3 जिसमें लिखा होता है सिर्फ टुमारो. तो यहां तक तो मैं पहुंच चुका हूं. अब बस ये मुझे इस फॉर्म में कन्वर्ट करना है. तो आप M1 में हेलो कितनी बार आ रहा है? टुमारो राहुल. ओके, मीट यू टुमारो राहुल, बाय राहुल, मीट यू टुमारो राहुल. सो हेलो वर्ड तो आ ही नहीं रहा दूसरे वाले में. राहुल आ रहा है, हाँ भाई राहुल 2 बार आ रहा है. राहुल यहाँ पर भी है, राहुल यहाँ पर भी है. बाय कितनी बार आ रहा है भाई? बाय आ रहा है भाई 1 बार. अच्छा, मीट आ रहा है, हाँ भाई 1 बार. यू 1 बार, टुमारो 1 बार. ठीक है. M3, अब M3 में क्या हो रहा है भाई? हेलो कितनी बार आ रहा है? सब 0, सिर्फ ये 1 बार आ रहा है. तो दैट मीन्स what I am getting out of this, guys, is this is a sparse matrix. Those who know matrix, again, matrix are of 2 kind, sparse matrix and dense matrix. Guys, can anyone tell me difference? If this is a 3x3 matrix, 3 rows and 3 columns, what do you mean by a dense matrix? What do you mean by a sparse matrix? करणदीप 0-1 की फॉर्म में नहीं होगा, इसलिए मैंने राहुल एक और बार यहाँ डाल दिया जिससे आपको क्लियर हो जाए. वर्ड कितनी बार आ रहा है ना? ओके. बट ये मेरे ऊपर था करमदीप, अगर मैं इसको बाइनोमियल नाइव बायस से सॉल्व करना चाहता था तो फिर मैं यहाँ पर सिर्फ ये करता कि वो वर्ड आ रहा है कि नहीं, बस 0101, वो मेरे ऊपर था। बट आइडियली यू अंडरस्टैंड राइट कि वर्ड के आने ना आने से फर्क नहीं पड़ता, वो वर्ड कितनी बार आ रहा है। अब कितनी बार किसी को बार बार बोल रहे हो क्लिक क्लिक क्लिक, दैट मीन्स यू वांट दैट पर्सन टू क्लिक, which is not good. Sparse matrix was 0. Yeah, very good, Pragesha. Very good. So the output that you are getting here, guys, is a sparse matrix. Sparse matrix are those in which most of the values are 0. And that's what will happen, because here I am talking about total words that exist in a book. Right? For example, अगर मैं पूरी हैरी पॉटर की बुक में जितने भी वर्ड्स हैं उनको अपना कॉलम बनाने की कोशिश करूं तो आप सोचो कि मिलियंस ऑफ वर्ड्स विल बी देयर, दैट मींस मिलियंस ऑफ कॉलम्स, एंड देन आई वांट टू सी चैप्टर बाय चैप्टर व्हिच चैप्टर कंटेन्स व्हिच वर्ड्स, फॉर एग्जांपल। तो some chapters will contain only few other words, some will contain other words, but some chapters, those who don't contain other words, will be 0 0 0, so it will be like a sparse matrix. So very less non-zero elements. Yeah, Pragisha, very less non-zero elements. Majority of the elements are zero. So this is known as a sparse matrix. और sparse matrix आप पाइथन में किस पैकेज से बनाते हो? पाइथन में कौन सा पैकेज है जो आपको sparse matrix बनाने में हेल्प करता है? Very good, Nishtha. Absolutely. NumPy is the best package. Then SciPy also there. SciPy, NumPy. But yeah, NumPy is there for numerical Python. So guys, this is what we will get, and then we can analyze the conditional probability. That's it. So let's see this. अब ये वर्ड्स के काउंट कैसे निकाले जा रहे हैं, वो बस काउंट निकालने की जो प्रक्रिया है वो सारी प्रक्रिया इन दोनों सेल्स के अंदर हो रही है, काउंट वेक्टराइजर एंड TF-IDF। ये TF-IDF एक बहुत ही फेमस एल्गोरिथम होता है हमारा NLP की फील्ड का। TF-IDF इसको हम कहते हैं गाइस टर्म फ्रीक्वेंसी एंड इनवर्स डॉक्यूमेंट फ्रीक्वेंसी। वही फ्रीक्वेंसी ऑफ वर्ड्स इन अ पर्टिकुलर डॉक्यूमेंट, कि एक वर्ड एक डॉक्यूमेंट में कितनी बार आ रहा है। डॉक्यूमेंट से मतलब है यहाँ पे मैसेज या ईमेल, व्हाटएवर। तो यूजिंग these two cells which I don't want to go into right now, our purpose is to reach out to this counts which is my final data frame. उसकी डायमेंशन आप लोगों को क्लियर हो रही है? ये टोटल मैसेजेस हैं और ये टोटल वर्ड्स हैं, लेकिन ये एक स्पार्स मैट्रिक्स है of the type numpy float with 72,000 stored elements. 72,000 stored elements only, but if you multiply these, how much it will give you? What happened? See, out of 45 million, out of 45 million, only 72,000 are the valid entries, means non-zero elements. So I could have saved this data in a data frame also. Can anyone tell क्या प्रॉब्लम होती है अगर मैं इसे pandas डेटा फ्रेम में सेव करता? मैंने इसे pandas डेटा फ्रेम में ना सेव करके एक numpy के स्पार्स मैट्रिक्स में क्यों सेव किया? Can anyone tell me why I am not using pandas data frame? Why I am using numpy sparse matrix? That very logical. Any idea? Yes or no? No, just yes or no. If you don't have any idea, it's fine. Ping me, I'm waiting. ओके ओके गाइस, देखो सीधी सी बात है, अगर आप पांडास डेटा फ्रेम बनाते तो वो मेमोरी में एक डेंस मैट्रिक्स बनाता, मतलब टोटल 45 मेमोरी स्पेसेस, 45 मिलियन मेमोरी स्पेसेस लेता वो मेमोरी लोकेशंस। चाहे उसके अंदर कुछ सेव करे ना करे, चाहे जीरो ही करे, तो इट विल बी हेवीली मेमोरी इंटेंसिव एंड इट वुड हैव रिजल्टेड इन अ स्लो ऑपरेशन। ठीक है। और अगर आप मान लो कि आप क्लाउड पे काम कर रहे हो जहां हर स्टोरेज का आपको पैसा देना है, या टाइम इज वेरी कॉस्टली बिकॉज मोर, जितनी देर तक मॉडल चलेगा उतना पैसा आपका कटता रहेगा क्लाउड में, तो you need faster processing. So NumPy sparse matrix will only use that much memory for only 72,000 elements, not for 45 million elements. So that's why we use NumPy sparse matrix, not the pandas data frame kind of dense operations. For faster computations, this is what is important for us. However, pandas data frames को भी optimize कर दिया गया है, pandas data frame को भी बहुत ज़्यादा optimize किया गया है. They also avoid these kind of problems now. However, I hope you understood the logic. NumPy sparse matrix is better as compared to any dense matrix based storage. Sparse मतलब खाली खाली. Okay, we don't want dense storage because our data is not dense, right? Our data is sparse. Remember this. Now I want to show you this data. One second. Why it's not coming? One second. ठीक है, this is a sparse storage, so 72,500 elements which it contains. That's fine, that's not a problem. Okay, so now we have the data. The question now is to split it, right? Now अब हमारा data उस form में convert हो गया है, जो ये format है, right? This is what we needed. We also have the target with each, whether it's a spam or not. In the train data, we already have that, right? So you have converted a text I was just trying to check the prior probability, but it's not printing. It's fine. Okay. So what's happening here is, you see, we have implemented the multi-linear model, fitted it, checked the accuracy of it. We checked the classes that, okay, there are two classes, 0 and 1, negative and the positive class, 0 and 1, which is whether it's a spam or not spam. where 0 says it's not a spam and 1 says it's a spam. So this is what we have predicted. Sorry, this is what we have done so far. Now let me change this to another model. We have Bernoulli also, right? So I'm just showing you whether Bernoulli works here or not. Okay, so this is what I was telling you. Ki Bernoulli by definition runs for the data which is like 0101, but I have done this in the past that it works fine on this also. Okay, and it even seems to be maybe giving you better accuracy, but don't go by that. Okay, if you want to see what it internally do, you can still go to site packages and check that. But remember, you have to use multinomial because this is the case of multinomial NB, not the Bernoulli. It may be internally handling it, but that's what you have to remember. So this is giving you 96. This is giving you a bit better. Okay, so now go to evaluating the model. So I'm just evaluating the model, and so wherever the predicted value is equal to mean value, I'm just predicted and actuals, wherever they are equal, I'm taking the mean of at how many places both these values equal. आप ये भी कर सकते हो, otherwise आप अपने अलग accuracy metrics भी use कर सकते हो to do that. Like we talked about the confusion matrix, and using that you can calculate the accuracy of this. Like there is confusion matrix, right? But what this guy is doing is, see, what here we are trying to achieve is कि out of total records how many are there जहाँ पे predicted और test same है और उसका mean ले total percentage of data which is matching is 94%. इस तरह से ये accuracy हो गई आपकी. Okay. If you haven't seen this, if this is actual 0 1 0 0 0 and predicted is 1 1 0 0 0, what I am trying to do here is I'm just trying to equal. So here it's false, but here it's true, 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 true. So I am saying 4 out of 5 are true. So I'm just taking a mean of that. Okay. So this is another way to check the accuracy of the model, or else you can go the confusion matrix route. You can build a confusion matrix and do it to calculate the accuracy of the model. So here we can do it from the confusion matrix. Then I can calculate the accuracy, right? This plus this divided by total. So 30 messages are still misclassified. Okay, 30 messages are still misclassified. Then I can create a heat map on top of it. I leave it to you guys to do it, looking at the previous notebook that I shared, how to create heat map, how to print all those other metrics. But from here you can do this, how to evaluate it. But this is how the model works. This only part which we will talk about when we will do your natural language processing content, like what is count vectorizer and what is TF-IDF, those steps. But till then, you guys should read about what A, given any text data, you have to uppercase, lowercase it, remove the punctuations, then remove the stop words or the bad words, do the tokenization, do the stemming and lemmatization using Porter stemmer, and then finally you just have to do the count using count vectorizer and TF-IDF, these two things, to finally reach out to this form, this form. And once you are in this form, it's as simple as any structured data. With this, I'll end the naive base here. Implement these models. I'll again upload this. I have done some changes. I'll upload them in some time, like 5 minutes. But before we end today's class, I want to start the next topic. Okay, you guys can get all these books and all these notebooks there. The remaining work for you guys is to complete this section. Okay, complete this section by printing heat map, plotting the classification thing and all those stuff. You have to do that, and then calculating the precision and recall, the TPR and the TNR, and the other things like misclassification or the error rate. Okay, I want all of that to be solved by you guys. You don't need this as such. I'm commenting it. I'm commenting this also. You can if you need. So remember what the sparse matrix is, how to store the data. That's to in the compressed form. So it saves you a lot of memory. Okay, it saves you a lot of this memory. So Gulzar, it's just that when you download this notebook, I pinged you. You have to complete the remaining part, which is here. And then I want you guys to use both the multinomial NB and Bernoulli NB and plot the ROC AUC curve. Okay. ROC AUC curve is a curve between which two things, guys? Can anyone ping me? ROC curve is between what? X-axis क्या होता है, Y-axis क्या होता है? ROC curve में X-axis पे क्या होता है और Y-axis पे क्या होता है? TPR versus FPR. Okay. No, it's TPR versus FPR or FPR versus TPR. Guys, I think you are missing something. It's FPR versus TPR or TPR versus FPR. Yanam, it's FPR versus TPR. Guys, please read it properly. It's FPR versus TPR, not the other way around. Okay. It's like 1 minus of sensitivity versus specificity. That's how this curve is. So read about it. I may also be wrong, but it's FPR versus TPR. FPR on the x-axis, TPR on the y-axis. I may be wrong, but just check it. Right? So x से FPR है, y पे TPR है. और इसको हम कहते हैं even 1 minus of I think sensitivity versus the specificity, or maybe again vice versa. So just check it. वही है कि ये रटने की चीज नहीं है, but at least you should remember few important things. If you look at the ROC curve, so if you're looking at it, is FPR versus TPR, as I told you, right? It's a FPR versus TPR curve. And we also say it's like 1 minus of specificity versus a sensitivity curve. Okay. Where if you see this blue one, it's worthless. This red is good, and this green is excellent. Okay. So even this dotted line, which I told you, was a random chance, right? Like 50-50% probability, random chance. Whereas this is ROC curve, and this yellow area, it's the area under the curve. Sometimes people confuses that area under the curve is only the area between this line and this curve. No, no, no. It's the area with the x-axis, the entire area, this entire area, okay? Entire area. So you should remember it's 1 minus specificity versus sensitivity. So that's something important. In some competitions, you have to even upload the ROC curves also, AUC ROC curves. Okay. So with that, we completed the naive base. Now I want to start the another topic. Very, very important. So till now we have talked about the regression. We did the ridge lasso regression. Then we did about the logistic and SVM, and then we did the KNN, and now the naive base, right? As per the model list, which I normally follow. So the next step is to go into the another set of models, the most important ones. ज़्यादातर आप यही use करोगे अपनी professional life में, which is tree models. So now we have to talk about the decision tree models, and decision tree models are actually of 5 to 6 different kinds. So guys, we are going to start with the decision tree. Okay. Once you understand decision tree, then I have to start boosting models for you. But I'll discuss these today. The bagging and the decision tree, जो आप already कर चुके हो. Okay, so that we'll start boosting. So decision tree में, guys, can you first of all tell me कि decision tree regression के लिए use होता है या classification के लिए? Guys, decision tree किस लिए use होता है? Both. Very good. अगर मैं उसे regression के लिए use कर रहा हूँ तो कैसे मुझे पता लगेगा final output? What it do at the end? Regression output कैसे मिलता है? How you get the regression output from a decision tree? No, Nishta. Confusion matrix तो accuracy के लिए है ना. I am saying कि decision trees को interpret कैसे करते हो आप? Created kind of bins like less than 50 probabilities. Okay. 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 So let me come here. So when we talk about decision tree, it's built something like this, right? This is what my decision tree is getting built. Yeah, Tanya, you gave the right answer. But let me go ahead to it. So normally, guys, you don't think from that lens, which is quite important. Is if this is your decision tree and it can be used for regression, how will you tell me that, say, for a given data, I am predicting how much loan should I give? Should I? So model is saying give him 10 lakhs loan. How I come to know that? How will you come to know that? You will see, okay, say the first column on which you have to do split, age less than 50. Okay, let's come here. Then let's say whether its gender is male or female. So male, let's come here, and then you fall here, right? But here, when your model, when you trained your model, you started with say 1000 records. Okay, you started with 1000 records. While building or training the tree, 500 records landed here, 200 landed here, 300 landed here. Okay, हो गया पूरा, and nothing landed here. Now the question is, this is your trained model. 500 records fell in this, 200 this, 300 this, 0 this. Now today I have a new loan applicant. I want to identify how much loan to give him. He comes and falls into this bucket where already 500 training records were there. Now यहाँ तो 500 लोगों का डेटा मेरे पास, किसी को मैंने 10 लाख दिया होगा, किसी को 9.5 लाख दिया होगा, किसी को 20 लाख दिया होगा, इसको कितना दूं? Can anyone tell me now other than Tanya? Guys, you get it? The question now. So now can you tell me? Training a model, a decision tree model, is nothing but building a tree, and ultimately at the leaf nodes, your population is distributed. Some 500 people at one node, some other. So now, right, guys, what Tanya just said, mean of the observations which fell in that bin. So Aditi, you are also a bit correct, but you also have to refine it. So it's like you have certain bins or the leaf node buckets. So it's always the mean of the data that comes here. Similarly, if it's classification, it is what? If I have to say whether someone is having a disease or not, out of this 500, 400 may have a disease, 100 may not have. It's the mode, majority vote. Right, guys? It's the majority voting. The max, the mode or the majority vote. So it's also known as majority voting or voting. दो हम यहाँ वोटिंग टर्म का इतना यूज नहीं करते क्योंकि वो हम तब करते हैं जब एंसेंबल मॉडल्स होते हैं, बट या इट्स लाइक दैट ओनली कि मोड वैल्यू यू टेक. बट वोटिंग अगर आप रैंडम फॉरेस्ट में भी बात करते हो तो वोटिंग होती है वहां पर भी, राइट, अक्रॉस फॉरेस्ट. तो वोटिंग दो तरह की होती है गाइस. एनीवन नो? जब 10 ट्री कुछ प्रेडिक्ट करते हैं तो हम उनकी मेजॉरिटी वोटिंग करते हैं, राइट, रैंडम फॉरेस्ट में. तो वोटिंग दो तरह की होती है. एनी आइडिया? आपने कौन सी वोटिंग सुनी है रैंडम फॉरेस्ट में? गाइज रैंडम फॉरेस्ट में जो वोटिंग होती है उसको हम कहते हैं मेजॉरिटी वोटिंग. वोटिंग दो तरह की होती है, एक होती है सॉफ्ट वोटिंग और एक होती है हार्ड वोटिंग. रीड अबाउट इट. ओके, सो नो गुलजार, सो रीड अबाउट इट. रैंडम फॉरेस्ट में जब आप वोटिंग की बात करते हो तो दो तरह की वोटिंग होती है, एक होती है सॉफ्ट वोटिंग, एक होती है हार्ड वोटिंग. व्हाट इज द डिफरेंस बिटवीन द टू? It's like simple voting plus or weighted voting. Okay, so soft voting and hard voting. Soft voting मतलब क्या हो गया कि मान लो हम 10 लोग हैं, सबके वोट की बराबर वैल्यू है, वो वही सॉफ्ट वोटिंग. हार्ड वोटिंग इज लाइक सम वोट्स, मतलब सम ट्रीज हैव मोर इंपॉर्टेंस, तो अगर उन्होंने बोल दिया कुछ तो उनकी बात मानी जाएगी. इट्स नॉट वीटो, इट्स नॉट लाइक वीटो में तो एक ही की चल जाती है, बट इट्स समथिंग लाइक दैट. इट्स वेटेड वोटिंग जहां पर 4 लोगों के वोट पे ज्यादा इंपॉर्टेंस दी जाएगी रादर देन अगले 4, बट उनकी इग्नोर नहीं की जाएगी. वीटो में तो सबकी इग्नोर ही कर देते हैं. तो सॉफ्ट वोटिंग एंड हार्ड वोटिंग, that is important. So by default the majority voting that we talk about is soft voting, which is used in the random forest, but there is hard voting also. So read about soft voting and hard voting. So whenever you want to do hard voting, you have to pass the weights also, कि उनके weights कितने हैं. That's another thing. Okay, so remember this guys, voting तो random forest में होती है, soft voting, hard voting. बट मैं यहाँ पर भी अगर कहूँ कि इन 500 लोगों के आपने तो मोड उठा लिया, मोड ना उठा के अगर मैं वोटिंग करवाना चाहूं तो मैं वो भी यहाँ कर सकता हूं, ठीक है, कि हर एक रिकॉर्ड को जो ऑब्जर्वेशन वेट दे दूं, तो weight is not of the votes, weight is of the tree, Gulzar. So if you have 10 trees, few trees can be more important than others. So there are a lot of reasons behind it, which tree to make more important. Plus, when I talk about decision tree, here you can give some observations more weight as compared to another observations. So it all depends on the domain. So ऑब्जर्वेशन लेवल पे भी वोटिंग की वेटिंग दी जा सकती है, ट्री लेवल पे भी वेटिंग दी जा सकती है. ओके, सो इट ऑल डिपेंड्स ऑन द डोमेन. Okay, so sometimes it may so happen that the trees which are getting created earlier, you can say they are more important. The trees which are more deeper are more important, or trees which contains specific features for splitting are more important. There can be n number of things to consider these weights, but you have to pass a weight vector while implementing weight in any of the statistical analysis. Okay, so this was one thing, guys, to give you some deep understanding of decision tree, how regression works, how classification works, how voting works, what is weighting in voting. Okay, now the question is, for creating a regression or a classification tree, how do I come to know which node should be the root node and so on? Can anyone tell me on which basis the node split criteria happens? Varsha is saying entropy, Nishta is Gini, homogeneity, info or Gini. Karandeep, correct. It can be either, guys. It's not that it can be entropy or it can be Gini. It can be either one. That depends what you want, because both have their own formula. Entropy has a different formula, Gini has a different formula. Very good. तो आप या तो एंट्रोपी यूज करोगे, एंट्रोपी के साथ जुड़ा है इंफॉर्मेशन गेन, या फिर आप गिनी इंडेक्स यूज करोगे, उसके साथ जुड़ा है गिनी गेन. ओके, सो एंट्रोपी के केस में हम इंफॉर्मेशन गेन कैलकुलेट करते हैं, पहले हम एंट्रोपी निकालते हैं, उससे हम गिनी इंफॉर्मेशन गेन निकालते हैं. अगर आप गिनी इम्प्योरिटी की बात करते हो तो हम गिनी गेन निकालते हैं. व्हाट इज गिनी गेन, वी विल टॉक अबाउट इट. Like same, like information gain क्या होता है? Can anyone tell me what is information gain? Guys, what is the formula for information gain? If you don't know, just ping no, but at least I need to know. Very good, Tanya. So, and information gain is the entropy of the parent minus the entropy of the child, right? No, you are correct. So entropy, this is the parent level and this is the child level. So I'll calculate the entropy of root node, say E0. Okay, then I'll calculate the entropy of this and do their weighted sum to get the entropy of this level, entire level. Entropy is not specific to this, okay? It's for this entire split. So I get E0 and E1. So information gain will be E0 minus E1. Okay. So guys, entropy ज्यादा होनी चाहिए या कम? Entropy should be high or low? For a good model, entropy should be high or low? Very good, Aditi. Yeah. So entropy is like the error or the randomness in a system. Okay. So entropy should be low, and information gain should be high. The more the information gain, the better it is. Means if this entropy of the root node was 100, okay, and after this split, the entropy came out to be say 90 for one split and another split 80. So which of the two split I will select? I will select 100 minus 90 is 10. So it's 10 of information gain. 100 minus 80 is 20. So I will select this one because earlier entropy was 100, after split is 80 और दोनों में difference जो है information gain which is 20, so 20 is better, right? So more information gain, the better it is. Similarly, if we talk about Gini impurity, guys, higher Gini is better or lower? In case of Gini, should Gini be higher or lower to decide the split? Guys, these are the foundational questions, okay? Okay, Karan. I don't contradict you guys. I don't want to contradict you guys, but that's the problem of internet. Somewhere people say Gini should be high, but at that time they are talking about Gini index. I don't use that actually. So whenever I talk about Gini, I talk about guys Gini impurity, and Gini impurity should always be less. But you guys must have seen some other formula. I will share my formula to you. But yeah, on the internet, if you look, half of the websites talk in different way. So Gini index is something else. Gini impurity is something else. So I talk about Gini impurity, and as the word impurity, impurity should always be less. So Gini impurity should be less and Gini gain should be high. So keeping it consistent, I follow only one approach. But there is another formula, Gini index, जो high होना चाहिए. But I will use this Gini impurity, not Gini index. Okay. But yeah, you guys are also correct. Those who are saying Gini is higher, because you are talking about Gini index. Okay. That's good. You guys know most of the things here. Now the question is, how many different types of decision tree algorithms are there, or different decision trees are there? Guys, anyone know types of decision trees? Okay, even before that, you guys didn't give me one answer. If this is the split happening, guys, if this is the tree split happening, आप लोग बोल रहे हो कि एंट्रोपी या इंफॉर्मेशन गेन के बेसिस पे स्प्लिट होता है, लेकिन वो तो क्लासिफिकेशन के केस में होता है. रिग्रेशन के केस में किस मेट्रिक को यूज किया जाता है स्प्लिट के लिए? गाइस, रिग्रेशन के केस में भी जब ट्री बिल्ड होता है तो क्या एंट्रोपी या गिनी ही यूज करते हैं? Read about it. There is something known as LSD, least square deviance. Mostly for regression, when we talk about splits, we talk about LSD formula. Your least variance should be there in each and every split. So when we build a regression tree, we focus on this thing, okay? Because the formula for Gini uses probability. How will you use probability on numerical data? You cannot. Probability will be used on the categorical data, right? So for regression, we use something known as least square deviance, या LSD. Read about it. So while building the regression, we look about the decreasing LSD. In classification, we talk about decreasing entropy. or we talk about decreasing Guinea index, Guinea impurity. Be very specific. Decreasing Guinea impurity or increasing Guinea index. So ideally क्या होता है guys? Decreasing Guinea impurity and increasing Guinea gain होता है. Guinea gain increases and Guinea impurity decreases. So remember this. Now, yeah, I was talking about types of decision trees. So Rahul is correct, cart. But before cart, there were a lot of decision trees that came in. Okay. Yeah, Rahul, you are correct. So guys, if you look at the types of decision trees, okay, आपने R में भी अगर देखा होगा, Python में भी. So when we talk about decision trees, like ये तो आज से 100 साल पहले, 80 साल पहले, 50 साल पहले भी थे. So normally when it started, it was iterative dichotomizer 3. Okay, ID3 models. Iterative dichotomizer is like, iterative means multiple cycles. Dichotomizer is like 2. So means splitting at 2 at every step. First step split 2. Next step it split into 2. So it builds you B tree. B tree means binary tree. Okay, so it's building the B trees and it uses entropy. ID3 uses entropy. But there were some problems with this ID3 performance and all. Then came C4.5 and C5.0. C4.5 और अब उसका एडवांस C5.0 है. They also uses entropy. They also use entropy, but in a different way. They introduced the concept of information gain, or what we say gain ratio, the information gain. So we can use these also. But these models are primarily used when we have multi-class classifications type of problem. Or instead of binary split, we want to do multiple split at each step. So we can use C4.5 and C5.2. Then there is this CHAD, which instead of using entropy or information gain uses the statistical test, the chi-square test. This is again for multi-way tree, the multipath, the multi-split. However, we talk about this, the cart, where we have both regression and classification. For regression, we use this LSD or decreasing variance, and your variance should decrease with each split. It should not increase the errors. Or Guinea impurity, which should also decrease. Can anyone tell me the full form of cart? Guys, full form of cart. Very good, very good. Thank you. So it's classification and regression trees. It's iterative dichotomizer. It's just C4.5. This is CHAD, which is like chi-square automatic iterative splitter something. You can check this CHAD trees, automatic iterative splitters. So these are the major different kinds of trees. We focus on the cart only, but see how the regression trees are being built using LSD and Guinea. Okay. Guys, in decision trees, there is how you optimize a decision tree, guys. Can you tell me? How do you optimize a decision tree? Please ping me. What are the ways to optimize a decision tree? Okay. Okay. So these are known as pruning, right? Pre-pruning and post-pruning, because we know that the biggest problem with decision tree is overfitting. And to avoid the overfitting, we prune or cut the tree. Like we cut the trees in our gardens, right? We don't want them to be growing exponentially. So we cut the unnecessary part of the tree. So that's what we do in pruning, pre-pruning and post-pruning, right? And pruning may there are something known as min bucket and min split, the most important parameters. You can also specify the height of the tree. That's there. So these are important things like pre-pruning and post-pruning, like min bucket, min split. The another benefit of using decision trees is explainability. मशीन लर्निंग मॉडल सबसे बढ़िया वो है जिसको आप अच्छे से एक्सप्लेन कर सको. तो डिसीजन ट्री आर द बेस्ट इन टर्म्स ऑफ एक्सप्लेनेबिलिटी. You can explain it to anyone easily. They follow some Six Sigma industry standard also. We are not talking of that. But explainability is the most important part. You can easily explain someone that why a particular decision was taken by just showing him this tree. It's easily to interpret and understand. Okay. प्री प्रूनिंग और पोस्ट प्रूनिंग में फर्क है कि प्री प्रूनिंग मतलब आप मॉडल जब रन कर रहे हो, ट्रेन कर रहे हो, उस समय ही आपको पता है मुझे क्या करना है, आपने स्पेसिफाई कर दिया. पोस्ट प्रूनिंग मतलब जब ट्री आपने फिट कर लिया, एनालाइज किया कि नहीं इस ट्री में कुछ गड़बड़ है, अभी मुझे इसको और कट करना है और स्प्लिट करना है, जो भी मुझे हाइपर पैरामीटर चेंज करने हैं, तो पोस्ट प्रूनिंग मतलब एक ट्री को ट्रेन करने से पहले आप कुछ काम करते हो, एक ट्री को ट्रेन करने के बाद आप काम करते हो. प्री प्रूनिंग एंड पोस्ट प्रूनिंग. This is another thing, like when to use a decision tree for prediction. So when you are using it for predictions, like continuous target, either you can use CART or you can use C4.5. तो C4.5 वगैरह हमें तब यूज करने चाहिए जब फीचर्स और टारगेट के बीच में नॉन लीनियर रिलेशनशिप है, राइट? नॉन लीनियर रिलेशन, देयर इज नो लीनियर रिलेशन. इट कैन बी अ स्क्वायर polynomial relation, it can be another relation, but if it's non-linear, these graphs, these trees handles them properly. Similarly, if your target is a multiple category, then also you should use C4.5 and C5 if target contains more than 2 classes. However, these trees are also good, but these are recommended, like you should use only C4.5 and 5 in certain specific cases, otherwise no need. Okay, so coming back to the implementation, let me ask you a few things there. So guys, I just want to revise these things before we go ahead. Meanwhile, can anyone ping me the formula for entropy? Guys, what is the formula for entropy? ये पूछे जाते हैं इंटरव्यू में. ओके, formula for entropy, formula for information gain. Entropy formula is P log P minus P log P, rather summation of minus P log P. It's summation of minus P log P, right? Yeah, it's summation of minus P log P. Then the formula for Gini impurity is summation of P into 1 minus of P. Right? Remember the formulae where P is the probability of the positive class. And 1 minus P is probability of the negative class. Simple. So you are multiplying the probability of positive and negative classes. That's it. So I'm just opening 3 notebooks for decision tree. So you guys can read them. Decision tree for regression, decision tree for classification, and one is the basics of decision tree. So if we talk about decision tree, guys, if you look here, I'm just talking about a decision tree regressor. And when we talk about a decision tree regressor, it has internally certain important parameters where this criteria, MSC, is something very important. But other than that, these are all pruning parameters where you say max depth, kitna deep wo tree hona chahiye, max features. Max features कोई मुझे बता सकता है क्या है? Guys, what is max features? Any idea? Guys, am I audible? Oh, sorry. Number of columns, variables, max feature alone in a node, max features to be, yeah, Varsha, that's the correct thing. So the point is, if I have split it and reached till this point, now I have to split this. And 4 columns. So should I try this split on all the 4, like all the 4 features? Or if I say here 2, then randomly any 2 of the features will be used for splitting, right? So that's what the max features is. So if you have say 400 features, you don't want that 400 features to be tested each split. It will be too slow. So you will say 20. So randomly any 20 will be picked for each iteration split. It will fast up the process. So that will be better. It saves a lot of time. Similarly, you have max leaf nodes, another pruning parameter. How many maximum leaf nodes can be there, like the last nodes. Minimum impurity decrease, another very important parameter. Minimum impurity split, min sample leaf, min sample split, and random state splitter. So all these are the most important things, but this criteria here you see is MSC, right? So let me show you that. So for regression, the criteria is MSC, right? Which is nothing but what I was talking about. The split should happen not on the entropy or the Gini, rather should be on the mean squared error. So your mean squared error should keep decreasing. So at the root node, your error can be more. At each next split, your error should decrease. So if you see here, guys, the criteria, the splitting criteria for regression is not Gini or entropy. Rather, it's either mean squared error or mean absolute error or the Friedman MSC, which is the modified form of MSC. Remember these things, these are important. Okay. So this is also known as variance reduction, the one that I was talking the variance reduction for the feature selection criteria, like which feature should be selected. So ultimately MSC is minimizing the L2 loss, MA is minimizing the L1 loss. It's just the losses that they are minimizing. Max features to use for the split, you can leave it to auto, where all the features will be tried. Okay, or you can give square root or log. So only square root of the total features will be tried for each split. So if there are 100, so I think only 10 features will be used for each split. So this is one of the good way. Or if you want, you can specify the exact number of value, how many features you want. But better to use a square root. There is this another important hyperparameter in decision tree, which is known as CCP alpha. So what is this CCP alpha? Is the cost complexity parameter. The cost complexity parameter is another statistical value. It's like you try 3-4 models, the one with least value of the CCP alpha, the cost complexity, once again, the subtree with the largest cost complexity that is smaller than this. So the one with the largest cost complexity that is smaller than CCP alpha will be chosen. So that means जो भी आप यहाँ पे वैल्यू दोगे, मतलब वो आपका एक थ्रेशोल्ड है, एज इन उतना कॉस्ट कॉम्प्लेक्सिटी आपको चाहिए ही चाहिए. यू नीड अ कॉस्ट कॉम्प्लेक्सिटी पैरामीटर. अगर आपने 10 बोला है, मतलब हाइयर द वैल्यू द बेटर द मॉडल in this case, cost complexity parameter. So this is not used much, but just for you, that CCP alpha is a parameter which is a cost complexity parameter. जो भी आपने threshold दिया है, जो भी उसके नियरर जिसकी वैल्यू आ रही है, closer to that will be selected. Okay, so the important points for you to remember here is, so the important things will be this criteria, read about it, it's not Guinea and all. Then the pruning parameters like max depth, min split, min leaf, all these parameters, and the max features that needs to be tried. And like Gulzar, you were asking about weights, right? So see, samples have the equal weight. When sample weight is not provided, it's like I am not providing any weight vector. So if here I have 500 records that get here, all of those will be having equal importance. But if I pass on the weight vector, then that can be different. So there is this place where I have to pass on the weight vector. But again, these are not needed in general. Okay. Similarly, this is the classifier, guys. This is decision tree classifier. And in classifier, the criteria can be either Gini or entropy. If you see, it's by default Gini, like cart model. It's the cart model. The cart model supports Gini, but if you want, it can support the entropy also. So the criteria is the most important thing. And then the pruning parameters are still the same, which we talked about. Max features, weight, all those, random state. Okay. So just go through the parameters and remember regressor split is different. So Gulzar, I'll tell you that in the case of ensemble models, because there we will talk about this thing. When we actually, what happens is when we create the boosting models, so in boosting, the trees which gets created early, they have more importance as compared to the trees which gets created late. So XGBoost or the GBM model gives the weights in that manner. So we will talk about that. Okay.
सर एक मिनट.
हाँ, एक सेकेंड.
Okay, apart from age.
Just a second, Gulzar, hold on. Yeah. So to answer your question, so what happens in the advanced models, each tree, when you talk about ensemble, each tree will have an importance associated with it, which is known as amount of say. And the amount of say is given by this formula, which is half of log of 1 minus total error by total error. Means if a tree is having more error, its importance decreases in the final weight, final voting. So normally if we talk about T1 plus T2, we say T1 plus T2 by 2 because the weights are 1 multiplied by 1. So actually ये 2 कहाँ से आता है? Which is this 1 plus 1 is 2. Okay. But when we talk about T1 having some importance W1 plus another tree T2 which have some importance W2, then we don't divide it by 2, rather we divide it by W1 plus W2. Okay, to get to the final value. So this is one of the formula. So everything is by formula, nothing is like a random. So each tree is having importance based on the error that it gave while doing the prediction, because we predict on each and every data. So we get this importance or amount of say. And then finally what happens is, if these are the trees, right? If these are the trees, इसकी amount of say 0.97 है, इसकी 0.32 है, इसकी 0.78 है, 0.63 है, based on that formula, log 1 minus error by error. Then what we do is, in case of regression, we do the weighted average. But in case of classification, what we do is, if this predicts, say, loan दे दो, and this predict भाई loan दे दो, and this predict भाई लोन दे दो and this says लोन मत दो, तो we see in accumulated, मतलब जो लोग हाँ कह रहे हैं उनका टोटल सम कितना है, वो कितने हैं, 3, वेरेज जो ना कह रहा है वो सिर्फ 0.63 है. तो here this wins. Okay, wait guys, just 5 minutes. Yeah, I'm also done. Yeah, Gulzar, I'll ask you a question. Is it making sense now? Yeah guys, just 5 minutes. Gulzar, is it making sense? Still any doubt? So you have a statistical. Yeah, go ahead.
सर पर इसमें ट्रीज को वेट असाइन का कहाँ से पता चलता है कि ट्रीज का वेट असाइन किए जाने के बारे में?
ये मॉडल जो एंसेंबल मॉडल्स होते हैं उनके अंदर ये एल्गोरिदम है, आपको नहीं बताना है. ये एल्गोरिदम ऐसे ही काम करता है. ये एल्गोरिदम ही खुद ऐसे काम करता है. आप इसको बोल नहीं रहे हो कि तुम्हें वेट लेना है या नहीं. जो आपके बूस्टिंग मॉडल्स होते हैं वो इसी तरह काम करते हैं. You are not specifying it. This is the formula using which the boosting model is identifying the importance of each and every tree. Okay, so boosting models internally take care of weights because you don't know on what basis should I give weights. So how will you tell, right? So model says leave it. मैं आपके लिए weights खुद decide कर लूंगा based on this formula. So what I am saying is कि soft voting and hard voting यही है कि random forest में सबकी equal importance होती है, जबकि boosting models में ऐसा नहीं होता. Boosting models में weight internally decide किए जाते हैं हर tree के based on this formula which is known as amount of say. Okay, you don't need to specify anything. It's just how soft voting and hard voting works. Okay, but as an advanced users, we also can do this. There are ways, but we are not going into that. Even in random forest, we can assign the weights, but I'm not going into that. But this is what I'm explaining you, how weighting works. Some models internally calculate it, like boosting, using this formula or other formula. But in some models, they don't use it, like random forest. If we want, we can pass the weights, but that's out of scope for us because we have to rewrite the model internally for that. Okay, but that can also be done. So people who write their own models or tweak the existing models do changes the code which is in the side packages, which I showed you guys, right? So as advanced users, we have to do it. We tweak the existing models as per our needs. But for you guys, it's not needed. But remember, it can be done. You can tweak any existing model. Even I can change this formula. Instead of log, I can say I want to use log base 10, or I want to use log base E. Yeah, Nishta, definitely. But I'm saying, see, by default it may use log base 10, but I want to use log base E. I have to change the code, right? Because I don't want to use log base 10 on amount of say. It all depends, right? If I want to change this formula, I have to change the internal implementation of the model. So all those things can be done. Read about it. Start, see, मेरा पर्पस यहाँ पर आपको सब कुछ पढ़ाना नहीं है. मेरा पर्पस है आपका just thought process develop करना. Just read on internet how to assign weights to different models in ensemble modeling, and you will get 1,000 different approaches. Read about them. Okay, what is soft voting and how hard voting is done. Hard voting कैसे weights assign करती है, तो Google it. Okay, मतलब I cannot definitely teach everything. Okay, so guys, with this tomorrow we will start with boosting, the XG boost, GBM, ADA boost, all the boosting models, because random forest is already done, right? So tomorrow we will start with the boosting model, the meta models. These are the meta models. boosting models. So we will talk about that tomorrow. So this is our class for tomorrow. We will start with some theory for this. Then we will implement this. And there are multiple types of boosting models. So we will talk about ADA boost, gradient boost, and XG boost. Some people have, I think amongst you only have asked about categorical boost and light boosting. So I will talk about these 5 models tomorrow, how they are different, these 5 boosting models. Okay. So okay guys, thanks a lot. It may so happen that tomorrow class starts early, maybe at 9 a.m. Okay, 9 to 11, because I have some work. I'll ask Damini to inform you by today evening. So we will have 9 to 11 tomorrow. I'll ask Damini to confirm it by 5 o'clock to you. Okay. Okay guys, thanks a lot.
Sir?
Yes.
Sir, are you taking classes offline?
No.
Okay.
Means I didn't get the question actually.
Sir,
No, I
are
didn't
you
get the
taking
question.
classes offline at the center?
Oh, at the center? No. I don't. Okay guys, thanks a lot.